Hello bachcho, Sat Sri Akal and Namaste from my side. First of all, thank you very much for a love that you showered in my previous teaser. I read all of your comments and I'm really overwhelmed by it. So again, a new teaser about this session is in front of you all and about all of those concepts that we are going to study in this lecture. Retardation, acceleration, free fall, the best case of motion under gravity. So students, this was a teaser of what we are going to study. The lecture, second lecture of Champion series of motion in one dimension is loading.
So that was a teaser, and it was just what we can say a fun element, a visualization of a specific topic in front of you all, right? So it was the difference was clearly shown, okay, between whatever the physics we are studying and what physics we are, what we can say. Right, we are seeing into the entertainment industry, but it's not a big deal, man. It happens, right? Okay, so sorry, I forgot. Hello bachcho, Sat Sri Akal and Namaste from my side. How are you all? So this is your own physics educator Indrajeet Singh welcoming you all onto the most sensible platform of an EdTech. Most sensible platform for an aspirants, those who are preparing for JEE and NEET kind of competitive examinations. As PW is a box of surprises, we are growing more. Our family is expanding, right? And we are always, right, in strive of doing something new. Hope so you like our initiative, right? In our previous video, we got an awesome comments related to my teaser. Thanks a lot for showering us a love, right? If you like this teaser for this specific topic, like for motion in a 1D kinematics, right? So kindly please comment beneath the video. I will be waiting for all of your comments. Again, I used to read all of those stuff, but I never reply as of some right XYZ reasons. But I will be waiting for your comments, especially related to the lecture also and related to the teaser also. Okay, so guys, let's start. This is a champion series. So champions, are you all ready? Yes, you all are ready. Champion series, right? It is a kind of a crash course for the JEE and NEET aspirants, right? And this is the second lecture. Okay, sorry, this is the third lecture. Okay, first lecture it went on for the units and measurement. After that, Akash sir took that electrostatic smart. See, 11th and 12th are moving on to the parallel manner, right? We decided in such a way because we need to cover a lot of things, right? From the very basic, we need to make you all a hero from zero. Right, so for that this parallel perspective was important, right? I used to complete, I will move on with the syllabuses of 11th and rest will be completed by right Akash sir. He is also a very my dear fellow, right? He is also a right very interesting personality, right? When we used to have a conversation, right? We learned a lot. I learned a lot from him. Okay, so now motion in 1D. So guys, you can see one visualization in front. Right, okay, so now without wasting our time, I think, okay, the contents we are going to cover in this specific chapter. We are going to move on with the fundamentals. Yes, we are going to move on with the fundamentals. Now what are the fundamentals? What stuff we are going to discuss within that? I'm going to show you all into the detail within just a small amount of the time. Okay, we are going to discuss some concepts of the uniform motion, some relevant equations, right? We are going to discuss the uniformly accelerated motion and the most important part of the uniformly accelerated motion, and that is motion under gravity. Apart from that, we are going to see, I have kept the separate graph section and graph conversion section. Separate graph, right? We're going to see the concepts of graph separately. Okay, I haven't included this kind of this stuff into the uniform and uniformly accelerated motion. No, a separate thing has been come, because this is a problem of the right maximum number of the students, right? This is a problem. Again, we are going to solve it. Fundamental, from the fundamental, what we can say, from the basics, right? We are going to just pick the stuff and we are going to move on to the top level, right? And I guarantee those who are like, those who will right stay till end of this class, and they are going to really enjoy this stuff. Okay. After that, we are going to discuss some concepts of the motion under gravity and the relative motion and all of the relevant PYQs, okay, related to this topic. And then usual, right? Okay, first of all, what will be the flow chart of this chapter? What will be the flow chart of this specific chapter? Okay, so let's discuss it. Okay, see, first of all, I want to tell you all, we are going to discuss with motion in, right, 1D. Okay, rectilinear motion we are going to discuss, right? Rectilinear motion. And obviously, if we are dealing with the kinematics, then we do not have to deal with the cause of the motion. See, the syllabus is right distributed in such a manner, right? In first chapter, it was quite different, that is units and measurement. After that, you have to deal with the kinematics, 1D and 2D, right? In that, the cause of the motion we haven't right discussed, and we are not even interested. After that, whenever we used to move on, after 2D, when we used to move on to the Newton's law of motion, yes, then we need to discuss with the cause of motion, and that is force. After that, slowly with force, we need to move on to the energies and work, and slowly to the rotational part. So this kind of the flow is there, right? Okay, so it's kinematics and dynamics without cause and with cause, right? This chapter and our next lecture will be completely, right, okay, it will be an analysis of the motion, right, without cause. Why force is acting, we are not, right, we don't have to take care for that. Why it is happening, yes, we have to just move on, whatever the data is given, apply the relevant concept. So that's the definition of kinematics. Just keep this thing into your mind. So now, motion. Okay, first of all, it will directly move on to the fundamentals. Now, what kind of the things we are going to discuss, right, in this fundamentals part? First of all, we are going to discuss the actual definition of the motion, right? Second, we are going to discuss the frame of references, right? Inertial frame and non-inertial frame. After that, we are going to discuss distance, right? Displacement, right? Path length, right? Okay, this thing we are going to discuss. Okay, after okay, this we are going to discuss this stuff. I'm extremely sorry. Okay, the speed, velocity, right? Okay, we are going to discuss average speed, average velocity, and acceleration. Okay, and most important, sign conventions. So this all of those stuff we are going to discuss into the fundamentals. After that, we are going to move on with the right uniform motion. Right, in the uniform motion, we are going to discuss with the definitions, right, relevant equations. Okay, after that, we are going to move on with the uniformly accelerated motion, right? UAM, it stands for uniformly accelerated motion. Okay, we are going to discuss the two important methods. The first, where acceleration of the system is constant. Second, we are going to discuss the calculus method, right? And generally we are going to discuss the fundamentals of graphs, right? The fundamentals of graphs. Okay, I think I haven't wrote that clearly. Okay, yes, graphs. After that, in this we'll have motion and the gravity. Relative motion. So this is an actual flowchart of the chapter, right? Okay, one theory, one MCQ, one theory, one MCQ, one theory, one MCQ, right? Okay, one theory, one PYQ, lots of visualizations, right? They are going to come. Okay, so guys, if you want to take the snap of this message, okay, this lecture is usual, as we said before, this is a champion series, and each is a one shot lecture, and this one shot lecture is going to be for approximately 4 to 4.5 hours, right? But as usual, I want to tell you all that if you are going to stay till end, right, I want to just have a pen and a paper with your, right, with you, right? Just have a pen and paper. Okay, so you can just have a snap, or you can just note down whatever the, you can just pause the video and note down whatever the important stuff you are in need for. Okay, so I'm moving aside, right? This is the actual flowchart of the chapter motion in 1D. Okay, so if you want to take a snap, just have it. I'm giving you the 5 seconds. It's 5, 4, 3, 2, 1. That's it. Now, let's move on to the most important part, right? And that is the motion. Okay, see, the most important point I already told you all, right? We are not going to discuss with cause. We are not going to discuss with the cause of motion. Yes, we are going to deal with the acceleration, but we are not going to deal with what source and how acceleration is applied. Okay, just mark my words. Again, I'm highlighting that stuff into the double inverted, right? I am not interested in what source, in what kind of the acceleration, right? Who is applying the acceleration? I'm not interested. How the source is applying the acceleration? I'm not interested. I'm only interested how acceleration is going to change the velocity and the related motion parameters. That's it. So that we are not going to deal with the cause. That we are not going to discuss with the force. We are not going to move on to the source, how it is applied, which kind of the force it is. No. Just motion parameters, velocity, acceleration, displacement, distance, average speed, time, and everything. Okay, so now what is motion? Right, you can see Burj Khalifa, Dubai. Okay, see, it's a very, very simple example, right? With respect to the reference point. Okay, let's give you all a, what we can say, an example in front. Okay, a very, very, very simple example. See, right now I'm standing in front of you all. Okay, you are stationary, you are the reference point. Okay, I am an object, I am a particle, right? And yes, the most important stuff in front of you all in this case, right, whenever you are not dealing with the cause, right? Okay, then right, we have to consider all of the objects as a particle. Right, now what is a particle, you all are aware of. We are not going to into the detail manner, right, to that specific part. We are not going to into that much detail, right? But the most important stuff that I'm going to discuss right now, you are the reference point, you are the observer. In our previous class of the units and measurement, I told you all, right, you are the observer, you are analyzing everything, right? A theory is going to come in front of you all and you have to access that stuff. Okay, you have to access that stuff. Okay, so now the most important thing, right, the most important thing, right, okay, just, right, motion. So the most important thing, see, okay, the motion, we are not going to discuss with the cause. Okay, now I'm giving you an example in front. Suppose you are an observer, right? As I said before, okay, you are an observer. See, suppose I am a particle, you are analyzing my motion. So initially I'm at the rest. Now, with respect to the reference point and time, reference point can be anything. It can be you, it can be surrounding, it can be another planet, right? Okay, indirectly it is a reference frame. Okay, so with respect to the reference point and time, I am changing my position. So it means, right, the particle is in motion. Now, very simple definition of the motion, right? The change of the, right, position of the particle. Okay, this change, right, of position of a particle, change of the position of the particle, right, okay, with respect to the time and reference point. Okay, with respect to the, right, with respect to the, okay, time, okay, and reference point. Okay, with respect to time and the reference point. If this is happening, we can say the object is in motion. If this is happening, right, we can say the object is in motion. It's a very simple stuff. Okay, so now can I say the object, if this is happening, object is right in motion. The object is in motion. Okay, so now let's move on to the right. This was the actual definition of the physics. Okay, now the second most important point, generally in maximum number of the cases we are taking t is equal to 0 as the reference point. In some of the questions of the NCERT, right, beyond this, right, the analysis of the motion has already been done. If you want to move on to the exercise based question on, right, whatever there is given into the NCERT, right, okay, so in one of the specific question, the reference point t is equal to 0 is not being taken, right. The observer in that question, the observer is analyzing from t is equal to -2 seconds. Now generally time is negative is not possible, but that spatial question is given, and it is a very interesting question if you are going to move on through that, right. You can just check out the exercise, right, of an NCERT. Okay, so now generally in maximum number of the cases till now, right, we are going to take the t is equal to 0 as the reference point, right. Okay, as I said before, right, apart from t is equal to 0, right, there exist some questions, right, but we are going to understand the concept using this stuff, right, and we are going to deal, right, automatically that thing will be already, what we can say, automatically that thing will be, what we can say, you will grab that concept. Okay, so in all of those cases we are going to discuss like this way only. Okay, so now this was a motion, right. See, lots of technical definitions are given, right. Okay, lots of technical definitions are there, but as usual I say to you all, we are not going to move on to that part. I'm only going to, right, represent that stuff which is easily understood by you all. You are having thousands of the reference materials, right. You are going to you are having your own you are having our package, or some of the students might have our package of PW also, right. So I'm going to discuss with you all that, right, lots of technical definitions. Even Google is also having some specific definitions, right. So if the reference frame is changing, if the person thinking is changing, then obviously that is going to create one controversy, right. So we are not going to move on to that part. Okay, so from now onwards, as I said in my previous sessions also, right, from now onwards, not from now onwards, from like all of my sessions, whatever I used to represent in front of you all, I always used to keep that stuff which is easily understood, right, because physics is like that way. Because if you are going to see from the 360-degree perspective, then never we are not going to understand this stuff, right, into the very easy or convenient manner, right. So first it was motion. Now we are going to move on to the most important fundamentals, that is a frame of references, right. Frame of references. Now what is a frame of reference? You can see this visualization, right. Okay, I am saying this, the same example I'm going to take. See, in previous session I also told that the same example we are going to see, and we are going to understand some multiple concepts, right. The particle is standing in front of you all, you are the observer, right. So the point from which observer is taking its own observation, it can be point, it can be coordinate, it can be any position into the three-dimensional space, it can be any vector. So this is a technical, but in very simplified manner, right. Same example, I am standing in front of you all, through one technical device you are analyzing the motion of the particle. Yes, now there are multiple possibilities. Either you are sitting stationary and analyzing, either you are in moving train and analyzing. Oh, Indrajeet sir is moving. See, I am at my home sitting on the table and seeing this lecture. I am stationary, observer is stationary, analyzing the motion. Oh, Indrajeet sir is moving. Okay, I have downloaded this lecture. I am sitting in flight, right. The flight hours are quite long. I am getting bored. So let's move on to the physics. Oh, flight is moving with some specific velocity. You are the observer. You are inside the flight, but now you are not stationary. You are moving, right. So, oh, Indrajeet sir is moving. So in my previous example, you were stationary, right? But now whenever you are analyzing my motion from flight, you are moving. You can just feel the difference, na? In first example, you were stationary. But whenever you are analyzing the motion in my flight, you are moving. Right? So in both of the cases, frame of reference is there. But both of the frame of references are different. So in this example, right, we have to just opt out the actual definition of the frame of reference that is easily understood by you all. The point from which observer takes its observation. A point, or we can say it is as a frame. We can say it as a frame. A very, very, very simple thing. Now, there is a possibility velocity of the frame might be 0. Observer is stationary. So that's why I've given the visualization of the telescope. The point from which I'm analyzing. Oh, Indrajeet sir is moving. Oh, I'm stationary. Indrajeet sir is moving. Yes, 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 yes. So I'm analyzing. So this is my frame. And that is the frame of reference. Why? Because from this point I'm analyzing the motion. Yes. So that's why I've given this, that's why I've kept the visualization of this telescope. The person who is analyzing from this telescope or from the whatever, the small device. Right. So the simple frame, see why I'm showing you all, why I've kept this definition of the frame of reference. As I said that we are going to start from the basics. None of a motion is analyzed without frame of reference. Right? Okay, see, I'm going to show you, I'm going to write one statement in front of you all. Right? I'm going to write a statement in front of you all. Right? Okay. Particle is never in absolute motion. See, I'm going to write. Particle is never in absolute motion nor at absolute rest. Never. Particle is never in absolute motion, never at absolute rest. Right? Okay. So in this universe, nothing like motion and rest exists. Everything. See, I'm going to I'm delivering the most important statement, right? You just highlighting. In this universe, nothing like motion, nothing like rest exists. Everything is just a frame of reference. Right? Everything is just frame of reference. Just a frame of reference. If I'm analyzing this stuff, I'm standing on the ground, the car is moving with some velocity, I'm analyzing, oh, car is moving. So the point of observation is stationary, but with respect to the ground of Earth. With respect to the person on moon, even this observer is also moving. So if the frame of reference is on the ground, yes, we are going to analyze this stuff. But if the same frame of reference, right, it has been analyzed from the else position, from another position, then things are going to change. Suppose I am imagining one planet that is exactly like Earth. Right? That is exactly. Suppose you are take yourself to the surface of moon. Okay, I'm standing on the surface of the moon. Yes, I'm seeing Indrajeet sir is delivering this lecture. Oh man, he is in motion. I am standing at the surface of the moon. Right? Indrajeet sir is delivering the lecture because the entire Earth is revolving around an right sun. So Indrajeet sir is moving because Indrajeet sir is present inside the Earth only. But whenever I'm moving right from the surface of moon near to the Indrajeet sir, here, right? Okay, here. Suppose you are here only. Imagine you are here. Yes. Hello, how are you? Fine. Khana kha ke jana, right? Okay, so you are here. Now you are analyzing. Now I am stationary. So it's all about frame of reference. Right? Frame of reference changes, things get changed, motions get changed. Okay, so that's why I've written particle is never in absolute motion, right? Nor at absolute rest. Everything is just a frame of references, right? Frame of reference. And that's why in my previous session I told you all, right? You are the observer and you have to analyze this stuff. Okay, so this is a most important note, right? If you want to take a snap, okay, or if you want to pause the video and just write that, okay, just write down in your book, okay, so you can just pause the video, okay, now. Okay, so frame of reference, hope so this definition is completely in all of your mind. Now let's move on to the type of frame of references. As I said you all, okay, I gave you the two examples. Basically there are two types of frame of references. First one, that is an inertial frame. Second one, that is a non-inertial frame. First one, it is an inertial frame. Second one, it is a non-inertial frame. Now what is inertial and what is non-inertial? As I said in my previous example, Indrajeet sir is like moving here and there, right? And being a student, you are an observer and you are analyzing the motion. Indrajeet sir is moving here and there. Being an observer, you are analyzing the motion. Yes, you are analyzing. It's a good thing. But if you are analyzing on the ground, being like standing on the ground, being stationary, right? Then your frame velocity is 0. You're not moving. Or suppose I'm analyzing this motion. See, I'm stationary. I'm analyzing this motion. I'm observer. My frame velocity is 0. Second, I'm analyzing this motion moving with the same velocity as the observer is, or as the object is having. Two cases. If I'm talking about the inertial frame, see, simple say, it's simple stuff. If I'm talking about the inertial frame, right, then frame velocity is 0, right, or frame velocity is constant, right? Frame velocity is 0. Frame velocity is 0. I'm analyzing the motion. Particle is moving in front. Oh, particle is moving. Very nice stuff. Very. Velocity of an observer 0. Frame velocity 0. But we can analyze this stuff. But if I'm talking about the second case, velocity of a frame is constant with respect to observer. Now observe that object seems stationary. Right? See, I'm analyzing the motion. Now object seems stationary. Right? See, this is object seems stationary. Okay? Object seems stationary. So that's an inertial frame and non-inertial frame. As I said, I've kept one visualization. See, this is a train. Let us take an example. If train is moving into the right side, there is observer, one inside and one standing on the ground. Right, for a person, for an observer who is standing on the ground, the frame velocity is 0. For a person who is standing on the ground, whatever he is saying, right, okay, he is saying this another object is also moving and the train is also moving. His frame velocity is 0. So that's a non-inertial frame. Now what about the non-inertial frame? The frame velocity, right, is not constant. It is continuously increasing or decreasing with respect to time. Right? That's a non-inertial frame. Right? This is an inertial frame. Right? And this is a non-inertial frame. Non-inertial frame means what? The frame velocity is not constant. Okay? We are going to take some time because we need some time to build the fundamentals. Right? Okay? After that, immediately we are going to discuss the stuff into the very rapid manner. Okay, so you can just analyze the flow of this chapter. First of all, we started with the flow of this chapter. I showed you all that diagram in front. After that, we moved on to the motion, right? After that, we moved on to the frame of references and gave you all the most important note. Nothing is absolute, nothing is at absolute rest, nothing is in absolute motion, right? Everything is just a frame of reference. Okay, the frame of reference is getting changed, everything is getting changed. Generally, we are taking the ground as a frame of reference, right? Okay, generally, the ground, or you can say earth, right? We are taking, okay, the inertial frame. Okay, generally the practical, if you are thinking, right, the earth is not also the inertial frame, because with respect to an else object, it is also moving. But if I'm standing on the land, right, of an earth, it means I'm stationary. That thing we need to assume, right? Okay, that thing we need to assume. So generally the ground, earth, we are taking is an inertial frame, right? Okay, and this thing we need to assume, because without that stuff, we are not going to understand this concept. Okay, so now this was the inertial and non-inertial frame, right? Hope so, right? You all are aware of that, right? Okay, you all got that stuff. We moved on from the frame of references, right, to inertial frame and the non-inertial frame. Now, let's move on to the next most important part, the most confusing part for students. So what about the sign convention? Somewhere we are going to deal with the stuff where downward is taken as a positive. Somewhere we are dealing with the stuff where upward is taken as a positive, right? So lots of confusions are there. Yes, we are not having the confusions either moving on to the left side or moving on to the right side. Okay, we are not having that kind of confusion, but yes, we are fully confused, right? Whether to take downward as a positive or upward as a negative. So if you are seeing this lecture, I am considering it's a crash course. Still, we are moving on from the basics, right? But not in, see, this is not as what we can say compared to the batch. You can we can't keep this stuff. We can't compare this with the Lakshya batch, right? With the Arjuna batch, this kind of whatever this batch we have moved on, right? Yakin batch, right? Prahar batch. Why? Because in that batch is a regular interaction with you all are going on to the PW app. Okay. So in all of those batches, we are just what we can say grabbing the student with us, right? And we are growing together. But in this, right? Okay, some assumptions we have to take. So right now I'm assuming that you all are aware of some of the concepts of the vectors. That is important because this is a crash course. As I said before, this is a crash course. So now, for maximum conventions, I'm talking about, right? Maximum. If the object is moving on, right? If I'm talking about the vector, I'm talking about the vector. Let us take an example. This is a particle. This is having the velocity towards the right side. If it is towards the right, I will take it as the positive I. If it's towards the left, I will take it as a negative I. If the velocity of the particle is towards in the upward direction, I'm going to take it as a positive J. If the velocity V is in downward direction, then I'm going to take it as a negative J. This is a simple convention, right? And all things will go with respect to the reference point, and that is equivalent to t is equal to 0. Another name of the t is equal to 0, I'm going to take it as point of projection. Or another, in some cases, right? Okay, I'm going to take the reference point as v is equal to 0. So what about the sign convention? Right side, positive I. It means the right side is positive, left side is negative. Vector, if vector is directing downwards, if vector is directing downwards, I will take it as a negative with respect to this reference point. With respect to the point of projection. Suppose particle is thrown upwards. It is thrown upwards, na? Upwards. So this will be the point of projection. This will be t is equal to 0. Point of projection. Right? Okay. So with respect to this, if particle is moving upward, right? Velocity is positive. Now, suddenly at max side, particle stops. Now, particle is moving downwards. So velocity is in negative direction. Right? So for sign conventions, okay, see, G is always in downward direction. So I'm taking with respect to the reference point, G is always negative, right? So this is a sign convention for the motion, right? This is the sign convention for the motion. Okay, all downward negative, all, see, vector is directing downwards, we are going to take it as a negative. Vector is directing upward. See, this same sign convention we are going to write. This will be quite helpful in all of those chapters, in maximum number of the chapters, right? The same sign conventions we are going to use, right? And apart from this, we are going to discuss with the clockwise and anti-clockwise and plus k minus k. For this chapter, so the same thing we are going to discuss it for all. The stamp, have a stamp, right? Okay, so this was a sign convention. Now let's move on to the next part, fundamentals, right? Okay, we are going to discuss with some definitions. Now, what is the position, right? What is the position? I'm going to take a very simple example and rapidly we are going to discuss this stuff, right? It was the evening time. Dad came back to the home from office and suddenly shouted, yes! After 2 days, we are going to move on for picnic. Wow, oh man, we are going to enjoy the lot because it will be the weekend and we are going to enjoy that. Papa, you are so awesome and most valuable and priceless asset in this world. Why? Because you are going to take us to the picnic. You're going to take us to the picnic. Now you are going to move on from home to the picnic spot. Suppose you are starting at 9 a.m. It's a 5-hour journey. At 10 a.m., what will be your position? At 12 a.m., what will be your position? Sorry, 12 p.m. At 1 p.m., what will be your position? Suppose, let us take an example. Same thing I'm going on from Delhi to Bombay. Right, from Bombay to Delhi. At 9 a.m., I'm going to start with the journey. At 10 a.m., what will be my position? Danu. At 11 a.m., what will be my position? Vapi. At 12 p.m., what will be my position? Surat. Right. In evening 7 p.m., what will be my position with respect to the reference point? Now, what is the reference point? The person standing on the Bombay, he is analyzing, oh, he is moving on from Danu to Vapi to Surat. Now he is moving on to the Udaipur and he is moving on to the Kota and he will move on to the Jaipur and Delhi. Yeah, nice, nice. So, at specific time instance, at specific time instant, the coordinates of the particle, right, at specific time instance, the coordinates particle with respect to, or with respect to, what we can say, not time, with respect to the reference point, right? Because of the visualization, right, some lag into the presentation is going on, right? Okay, in very simple terms, if I'm talking about in very simple terms, at specific time instance where object is, at specific time instance where object is, at 10 a.m., right? Okay, at 10 a.m., at 12 a.m., 12 p.m., 1 p.m., what will be the position? Suppose this is a three-dimensional space. This is x-axis, this is y-axis, and this is z-axis. So with respect to this reference point, right, t is equal to 0. Suppose it started from Mumbai, right? So this is the position of the particle A, right? This is the coordinates, right? Okay, after some time, this will be the coordinate of particle B with respect to the origin or reference point. So that shows the origin, that's position, right? That shows the position. So same visualization is there in front of you all. Okay, see, at t is equal to, let us take an example, 0, the particle is going to start the motion, right? At t is equal to 50 seconds, this will be the position of the particle. At t is equal to 25 seconds, this will be the position of the particle. At t is equal to 35 seconds, at t is equal to 45 seconds. See, you can see the positions, multiple positions of the particle, right? So this will be, right, position 1. Okay, this will be position 2. This will be position 3. And this will be the position 4. So at specific time of instance where object is, that shows the position at specific time instant. See, lots of, as usual I said, lots of technical definitions are there, but I'm not going to on that much part. Okay, now path length, okay, position, path length and displacement. Okay, so there is a small difference, right, between position. See, four terminologies are there: position, path length, distance and displacement. We are having a confusion between the distance and displacement, right? What is the distance and what is the displacement, right? Okay, what is the distance and what is the displacement? Okay, see, oh man, just hold on. This is a fancy as of the visualization. See, this is the distance. Instead of moving on to the difference between, the explanation of the distance and displacement, right, we are going to discuss, right, the difference between distance and the path length, right? Distance and the path length, right? Distance and path length, a very small difference, and both are one and the same thing only. Suppose, let us take an example. Particle A, particle is starting from position A and moving on to the position B, right? First of all, it move on in this direction and it will move on to this direction, and again it will move on to this direction and this direction. This is the position. This is what the path particle is taking, right, while moving on from A to B. Okay, now while moving on to this time interval, right, so of T1, particle moves for time T2, for T3 and for T4. This is the time interval of the specific. Now what is the distance and displacement? If I'm talking about between A and C, right, the path length covered in specific time interval. Again, I'm highlighting my points. The suppose between A and B, right, see, the visualization is there in front. Okay, this white is the path object is taking. Between A and B, right, the white is the path object is taking. Suppose path length of specific time interval, path length of specific time interval, right? Path length of specific time interval. Suppose, let us take an example, right, for A to C, right? You can see for A to C, in between A to C, there is one specific time interval. What is distance, right? It will be D1 and D2. So distance, we can say the path length, right, that will be is equal to D1, right, plus D2. But this is not for entire journey. In entire journey, I'm talking about one small time interval. In entire journey, I'm talking about one small time interval, that is from A to C, right? So that will show the amount of the distance covered or amount of the path length covered, right? Amount of the path length covered. Now, apart from this, right, what will be the actual path length? There is a difference between distance and path. Path length is for entire journey. Distance in entire journey, right? Okay, distance in entire journey. So this is path length in specific time interval. This is distance covered in entire journey. This is always positive, right? So this is the first important thing. Second, right, always positive or zero unless object is stationary. Unless the object is stationary, right? Suppose if I'm moving from home to office, right, then lots of distance intervals are there, lots of time intervals are there. So between any specific time interval, I can say it's distance, right? For entire journey, the total distance covered, that is path length. Total distance for entire journey covered, that is path length. For specific time interval, we are going to deal with the distance, right? So that's the path length and distance. Now let's move on to the next part, and that is of the displacement. Displacement, the same example we are going to take in front, right? As I said, suppose the particle is starting from A, right? Okay, it is its final destination is B. First of all, it is moving like this way, then it is moving like this way, then path is like this way, followed right by this path to reach the destination, right? Okay, so this is what an actual motion of the particle, and it has been analyzed, right, with respect to, right, one inertial frame, and that is observer on the ground. Okay, see, if motion is coming in front of you all, right, and we used to forget to tell you about the frame of reference, then automatically you all need to consider that stuff, right? Because in the previous part only I told you that without frame of reference it is nothing. It is just a controversy, right? So if particle is moving like following this path, right, then this is an observer, right? With respect to ground, it is analyzing the motion. Okay, it is analyzing the motion. Now, okay, see, it's a displacement. Displacement, it is a vector, right? The direct vector between the two positions, right? The direct vector between the two positions, that is the displacement. Or in another sense, suppose if I'm talking about the A to C, the shortest distance. Suppose if I'm talking about A to C, right, then what will be the shortest distance? Right, this will be the displacement. If I am talking about, see, if I'm talking about the two positions A to C, what will be the displacement? Right, this will be the displacement, right? If I'm talking about the another two positions of the particle, suppose C and B, right? The first position we all saw that displacement is this, right? If I'm talking about the second most important thing, and that is between C to B, what will be the displacement? Right, between C to B, this will be the displacement, right? Between C to B, this will be the displacement, right? Okay, now if I'm talking about the third position, right, if I am talking about the third position, then what will be the displacement? Third position, it means between A to B. What will be the displacement? This is the shortest distance between A to B. Yes, path, the object followed this path, right? Object followed this path, but I'm talking about the very right, the shortest distance between A and B. So for that reason, the visualization has been kept. For that reason, this visualization has been kept, right, in between point A, right, and between point B, right? Object is right taking multiple paths. First path is like this way, right? Second is a direct way. Okay. Why I didn't told that it is the shortest path, right? You all are aware of the, right, the actual definition of the displacement. You all are aware of the actual definition of the displacement, right? In some of the reference material, it has been written the shortest distance between the two, right? Okay. The shortest length of the vector between the 2 points, right, of a particle that is performing the motion. The shortest length of a vector, right? In between A to C, what will be the shortest length? This. In between C to B, what will be the shortest length? This. In between A to B, what will be the shortest length? This. Right? Okay. See, you can see in between A and B, multiple paths we can take. This one, this is a direct. So displacement, to understand it, see, lots of, as I said, lots of technical definition are there. To understand into the appropriate manner, right, the shortest length of vector between 2 points. the shortest length of the vector. That is a displacement. Okay, in another sense, you can also say instead of this length of the vector, you can also tell it as a vector, because length of the vector will give its magnitude, right? And vector, right, it's a different, it has magnitude and direction both. Okay, so to understand this, right, we are going to, okay, discuss one example, or we are going to discuss, right, the difference between the distance and displacement. First of all, we moved on with the difference between distance and path length. Now we are going to move on with the difference between the distance and the displacement. Okay, so now, okay, distance, displacement. Distance, always positive, right? Displacement, either it can be positive, either it can be negative, or it can be zero, right? Second, distance is a scalar quantity. It means it is having only magnitude, right? Displacement, it is a vector quantity. It is having both, right, magnitude, direction, and even it follows the right triangular law of vector addition. This is what the definition. Three types of terms are there, na? Right? Scalar, vector, and tensor. Right? Scalar, vector, and tensor. Three kind of terminologies are there, na? Scalar, vector, and tensor. Okay, so this is a scalar quantity, this is a vector quantity, it is having magnitude also, it is having direction also, and it follows the triangular's law of vector addition. Okay, third point, see, first, distance is always positive, displacement is positive, negative, zero. This is a scalar quantity, this is the vector quantity. Now the third most important point, right, we are going to discuss. Okay, the third most important point we are going to discuss. Now let's see. The third one is distance is the length of the path. Right? Either for specific time interval or for entire journey. Or for entire journey. Right? But this displacement, it is a shortest vector. It is not a shortest distance, nothing. Shortest length of the vector, no. Shortest vector. Because it can be positive, it can be negative, right? It is having magnitude, it is having direction, right? Lots of things are there, right? Okay, so this is a distance, right? This is a displacement. In another terms, we are also having one another terminology, right? Distance is sometimes, right? Okay, the magnitude of displacement, right? Or sometimes it is also, in all of those stuff, the distance is always, right, greater than equal to displacement, right? So these are some noteworthy points, right? And the actual difference between the distance and displacement, right? And some of the noteworthy points related to it. The actual difference between the distance and displacement, right? And some of the noteworthy points related to it. Okay, some of the noteworthy points related to it. So guys, if you want to take a snap of it, if you want to note it down, just pause the video, right, and just note down the important points, right, because this will be on the black screen, right, and this black screen, right, will not appear until the notes. Okay, so this will be on the black screen. Okay, so guys, come on everyone. Okay, so you can just pause the video. I'm giving you all the 5 seconds. 5, 4, 3, 2, 1, and that's it. Okay, so that's why shortest vector, more precise between 2 points on, okay, between any 2 points, the shortest vector between any 2 points in 3-dimensional space, right, for a particle that is performing the motion. Okay, now see, let's move on to the first sum. A man goes 10 meters towards the north, then 20 meters towards the east, then its displacement will be what? Right? Simple, right? Okay, see, suppose let us take an example. This is north, this is south, this is east, this is west, right? Okay, generally this is east and this is west, but I have rotated this figure at 30 degree. I've rotated this figure, right? Okay, it is a kind of the isometric view, the 3D view of this stuff, right? To understand this sum very well, it has been asked into the 3 competitive examination, right? Okay, it is a very simple sum of distance and displacement. Okay, it is a very simple sum of distance and displacement, right? And we are going to solve that stuff. Okay, so now to understand this, I've taken this isometric view, right? To understand, right? To you, so you can all can understand this concept easily, right? See, first of all, let us take an example. Particle is moving right from t is equal to 0. This will be my reference point. Okay, man goes 10 meter towards the north, right? 10 meter, right? This is a distance that is covering into the north, right? Now it is going 20 meter towards the east. So after reaching to the firstmost position, right, again you will get confused. Now what is the solution for that? This will be north, this will be south, this will be east, and this will be west. Again, make another convention, right, to the first position of the particle. Another make another convention, right? Or you can just write down here. Now it is moving right towards the 20 meter east, so it will be easy. 20 meter towards the east, right? Okay, so this was the starting point, right? And this is the end, the destination. Now we need to calculate the displacement. See, simple, we can calculate it by using the Pythagoras theorem, right? So it is, okay, under root of 10 square plus under root of 20, right? Okay, under root of 20 square, so that will be under root of 500, so that will be under root of 10 root 5, so that is 22.5 meter. This will be the displacement, right? Okay, displacement in another sense. See, if I'm talking about, suppose this is north, this is south, this is east, this is west. If I'm not taking the isometric view and solving it by using the method of vectors, right? Solving it by using the method of vectors, right? Now let's move on. See, suppose it is moving 10 meter towards the north, right? 20 meter towards the east, right? Okay. Okay, so this will be my R1 vector, right? That will be 10 of, it is moving towards the north, right? Suppose if you don't move on to that much, right? Okay, that much part, I can say, you see, this is the displacement. It is vector also, and magnitude of that vector gives its length, right? If right now I'm not moving on to the vector part because lots of things we need to discuss, right? So that's why. Okay, so here you can just apply the Pythagoras, 10 square plus 20 square, so your answer will be 22.5 meter. Okay, a very simple question of the distance and displacement. Okay, now a body moves 1/4 of the circular arc in the circle of radius r. 1/4 of the circular arc. Particle is starting from A reaching to B. This much amount of the arc it is covering. What will be the distance? What will be the displacement? Right? Okay. Say displacement is the shortest length or shortest vector. Its magnitude, it will be its length. So shortest vector. This will be the displacement. So can I say, suppose this is position A, this is position B, right? Okay, this distance is R, this distance is R. So this will be its displacement. This will be 90 degree, right? And this will be its displacement according to the Pythagoras theorem. Can I say it is R root 2? According to the Pythagoras theorem, can I say it is R root 2? But what about the distance? This is an, right? Distance is actually arc covered, right? Distance is actual arc covered on completing 1/4 part of the circle. On completing 1/4 part of circle. Right? If I'm completing the entire journey, my distance will be 2 pi r. So what will be the general formula? Theta into r. This will be my general equation. This will be my general equation. If it is completing the entire circle, the angle covered, the angular displacement will be 2 pi. So the distance covered will be 2 pi r. If I am talking about the 1/4 part of the circle, then what will be the theta? Pi by 2 r. This will be the distance covered by the particle. Suppose let us take an example. If you want to move on to the distance between A and C. What is the distance between point A and C? Suppose if this angle is, right, 120 degree, right? So between A and C, this is just an extra information. D will be theta into r. This will be 2 pi by 3 into r. Okay. So for this, right, okay, distance is pi r by 2 and displacement is r root 2. Okay. The A will be the perfect answer for this specific question. Okay. Now, the displacement of a point of a wheel initially with contact. See, wheel is rolling from, okay, when the car moves from one point to another point, right? You can see here, suppose it starts from, suppose this is a point P, this is the initial position. After completing half of the revolution, this is its new position. Half of the revolution, then what will be the displacement between initial and final point? Obviously, vector. The shortest vector or its specific length. The shortest vector or its specific length. You can all solve all of those stuff by vectors also, right? But that is an additional information. This is not needed right now. That's why we are moving on to the direct calculations, right? Suppose this is an initial point, right? This is a final point. Between initial and final, half of the revolution is completed. Half of revolution is completed. Now in half of the revolution, obviously the distance will be this, theta into r. Theta will be for half of the revolution, it will be pi r. So distance covered by the particle will be equivalent to pi r. So that's why it is written as the pi r. Now what will be, see, this is r, this is r. What will be its displacement? The shortest vector or its specific length. So we have to just apply the Pythagoras theorem, and right, we are going to solve this stuff. Okay, on applying Pythagoras theorem, right, this will be r plus r 2r. So it will be 2r square plus pi square r square. So this will be equivalent to r, right, pi square plus 4. Right, this will be the displacement of the particle. Right, this will be the displacement of the particle or a point P. The displacement of a particle or a point P on completion of the half revolution of the circle. Right, on completion of the half revolution of the circle, the B is the perfect answer for this specific question. Okay, so now, see, rapidly we are moving on to what we completed till now. Okay, see, we moved on to what is an actual definition of the motion. Right, okay. We have moved on to actual definition of the motion. I show you on the visualization. Then we moved on to the frame of references, then inertial and non-inertial frame of reference. Right, I gave you all an examples. Right, sign conventions. Right, what we are going to use in this lecture. Okay, we got to move on to the positions. We moved on with the path length. We moved on with the displacement. We moved on to sums of the, right, distance, displacement, position, path length. Right, 2 to 3 sums I showed you all in front. It was very simple. That's why I moved on. Now, next part, that is speed and velocity. Right, speed and velocity. Okay, there is a small difference. See, it appears, see, dimensionally, speed and velocity, with speed and velocity both are having the same dimensions. Speed and velocity both has the same dimensions. So dimensionally, it appears to be same. Sometimes, right, there arises a misconception. Sometimes speed appears to be same as like a velocity, but there is an actual difference between them. Right, so I kept that stuff. Speed, right, if I'm talking about the speed, right, it's a distance covered by object per unit time. Okay, see, just hold on. Okay, speed, distance covered per specific time interval. I told you all, there is a difference between distance and path length. There is a difference between distance and displacement, right? Distance for specific time interval, path length for entire journey. For distance, we are having speed. For path length, we are having average speed. For displacement, we are having velocity. Right. Okay. So this stuff is going on. You are having one visualization in front. The particle is moving, right? The motion of the car. What is speed? Distance covered per unit time. It displacement, right? What is a velocity? That will be displacement in specific time interval. Right. One is a scalar quantity, SI unit is same, right? SI unit in both of the cases is meter per second only, right? Okay, SI unit is same, dimensional formula is also same. One is a scalar quantity, second is a vector quantity. Why velocity is a vector quantity? Because displacement is a vector quantity and it results the velocity to be vector. And even we all are aware that velocity is having magnitude and direction. It also follows the right vector law of addition. So that's why it is a vector quantity. Now let's move on right to the next part, average speed and average velocity. Right now this thing we are going to discuss very rapidly, because after that we are going to discuss the concepts of the uniform motion, and then we will move on to the uniformly accelerated motion. We are going to discuss the graph, right, motion under gravity and the relative. So now average speed, the ratio of the total distance. Obviously I said that, right, average speed is what? Right, average speed, path length, the total distance traveled for entire journey, the time of entire journey. What is an average velocity? The ratio of the net displacement to particle average velocity. See, speed for specific distance, specific time interval, ratio of specific distance, specific time interval. Velocity, specific displacement between 2 points, right, to specific time interval. Average speed for entire journey, average velocity for entire journey. That's the difference between speed, velocity, average speed and average velocity. Rest of the things we are going to have same. This is a scalar quantity, right? Okay, this is a scalar quantity. Okay, this is a vector quantity. Okay, average velocity. Okay, average speed is always positive, right? Average velocity can be positive, negative, zero, right? It completely depends on the displacement, but average speed is always positive unless if object is stationary, then it is zero. Average speed can't be negative, right? Okay, and average speed is always greater than to the magnitude of the or equal to the magnitude of the displacement. So this is the difference, right? You all are completely aware of, right? Average speed, average velocity, speed, velocity, distance, displacement, position, path length, everything. Apart from this, we are going to have the new stuff, that is instantaneous speed, instantaneous velocity, right? Okay, instantaneous speed and instantaneous velocity. Now, instantaneous speed is the magnitude of the instantaneous. Okay, if you are going to understand this instantaneous velocity, na? Okay, so that will be instantaneous velocity, right? It is defined as dx by dt. When see, there is a slight difference, right? Slight difference. Why we are using this equation? Whenever the velocity depends on other motion parameter, whenever the velocity depends on other motion parameter, like velocity is depending on time, the change in velocity is depending on time, the change in velocity is depending on the acceleration, right? The change in velocity is completely depending on the displacement, right? Okay, in those cases, generally in the cases of non-uniform motion and in some cases of the uniformly accelerated motion, we are going to take the instantaneous velocity. At specific time, what is the velocity? As I said before, position. If I'm moving on from home to picnic spot at 9 a.m., what will be my position? So at that time instance, what is my velocity? At 12 p.m., what will be my position? Suppose I'm moving on from Mumbai to Delhi, right? I cross Danu at 10. So at 10 a.m., what will be my position? Danu. So at that instance, what will be my velocity? Instantaneous velocity. If I'm crossing up to the Surat at 12 p.m., 1 right p.m., what will be my position at time instance 1 p.m. Surat? At what time will be my velocity? At that time instance, it's instantaneous velocity, right? Okay. So instantaneous velocity is the rate of a change of the position with respect to time at any time instance. So that is a change of position, right? Okay. Either the position is rapidly changing with respect to time, right? Or it is changing, right, at the very, what we can say, either it is changing very rapidly. In another sense, if I'm talking about the very summarized form, if I'm talking about, right, the change of the displacement, right, is completely depending on another motion parameters. We can't analyze it. We are not able to analyze it. See, whenever we are not able to analyze any motion parameter, that's why its dependency is given. Like x is directly proportional to t is given, v is directly proportional to t is given, x is directly proportional to t square, x is directly proportional to v square, right? This kind of things are given, right? So in this thing, we are not decided how the rate of change of displacement is going on, how the rate of change, they are non-uniform. In some cases they are uniform also, but in maximum cases if this kind of things are coming, so right, the rate of change of motion parameter is not, we are not able to identify that stuff. So for that purpose we are using this kind of relation, and this instantaneous velocity concept has been introduced. Instantaneous velocity concept has been introduced, right? Okay. So the magnitude of instantaneous velocity, see, this is a vector quantity, na? Right? So magnitude of this vector is an instantaneous speed. At that position, what is the speed? See, there is a very simple difference. You all might get confused. Position at specific time instance where object is, what is its coordinate? So at that time instance, what will be the velocity? Instantaneous velocity. At that time instance, if instantaneous velocity is a vector, what is its length? Instantaneous speed, right? So its position, instantaneous speed, and velocity, keep it aside. Now distance for specific time interval, for that we are having speed. Displacement for specific time interval, for that we are having velocity. Average speed for entire journey, average velocity for entire journey, the net displacement with respect to time ratio. Right, so that is the difference. Anna, rapidly if I want to, right, tell you all, okay. For position, right, we are having instantaneous velocity, right, and magnitude of instantaneous velocity is instantaneous speed. This is the first part, separate. For distance, we are having speed. For displacement, right, we are having velocity. For distance, we are having speed. So this is for specific time interval. For entire journey, we are having what? Average speed, average velocity. So this is an actual classification, right, of all the fundamentals points, right, of the motion. All of the motion parameters are there in front. Position, path length, distance, displacement, everything is there, right? Don't get so much confused, right? Okay. If you are facing that kind of an confusion, I want to tell you all that just rewind this video, right? Okay. And just move on to the each and every aspect and just note it down. Move on to each and every aspect and just note it down. Move on to each and every aspect and just note it down. Everything will be cleared. Okay. If you want to take a snap, because it is a black screen and you are not going to get this stuff into the notes, right? So now let's move on to the next part. Okay, let's see some related. See, if we saw the sums related to distance and displacement. Now let's move on to okay, some stuff of velocity and all of this. In 1 second, particle goes from point A to point B. Okay, it is covering the semicircle of radius 1 meter. Magnitude of the average velocity. Okay, see, what is the formula of average velocity? Okay, I didn't move on with all of those formulas, right? Average speed, right? It is total distance by total time. Speed, it is distance by time, right? Average velocity, displacement, the net displacement, right, by total time, right? Velocity, that is, right, displacement for time interval, right? This is what a formula of is. Instantaneous, that is equal to dx by dt, right? Or that is limit, if delta t limits tends to 0, that will be delta x by delta t, right? Okay, you can just pause the video and have a snap of it. Okay, now average velocity. Average velocity will be equivalent to displacement, right, for time. Now, journey of the particle is from A to B. What will be the displacement? The shortest vector, 2r. So it's 2r by what will be the time? It is given, right, semicircle 1 second. Okay, so it's 2 into 1 by 1, right? So average velocity, right, that will be equivalent to 2 meter per second. A very simple question, right? A will be the perfect answer. Okay, A will be the perfect answer. Here you can also calculate the average additional information, average speed, right? Or you can say speed or average speed for this one, it's one and the same thing. Okay, distance will be pi r. Now half of the semicircular, the distance will be pi r, na, right? Okay, and time will be obviously for 1 second, right? The average speed will be 3.14 meter per second. This will be the average speed, this will be the average velocity. See, there is a difference. Okay, you can just analyze the difference between the average speed, right? It's 3.14, average velocity is 2 meter per second. Okay, now the motion of the particle is described by, see now, the motion of the, see, the displacement of the particle is depending on something. Now here comes the concept of instantaneous velocity. Here comes the concept of instantaneous velocity. The displacement of the particle depends on x is equal to a plus bt square, right? It can be x is equal to bt cube, x is equal to bt cube by 4, x is equal to bt by 4, x is equal to bt by 5, something. Any relation is given. So if this equation is given, then we are not completely aware, right? Why this equation is given? Because between two time interval, right? Suppose between t is equal to 0 to t is equal to 1 seconds, right? Or lots of variations are there. And we are not actually able to identify that stuff. So for that reason, this kind of equations are given. Now what we need to calculate the instantaneous velocity at time 3 seconds. Right, so let's differentiate this equation with respect to time. Right, so what we are getting dx by dt, so that will be your instantaneous velocity, right? So this will be d by dt of a plus bt square, so this will be 2bt. What is the value of b3 for what time? 3. So it is 2 into 3 into 3. So it is 18 centimeter per second. B is a perfect answer. In this cases of instantaneous velocity, instantaneous acceleration, right? in all of those stuff, you have to just use the calculus method, right? See, this is a part of the calculus method. Now, what actual the calculus method is, we are going to discuss into the very few minutes of this lecture after this part, right? So this is an instantaneous velocity. Now, let's move on to the, see, till now we have moved on to the fundamentals of this chapter. Okay, one thing that is remaining, and that is an acceleration, right? But that acceleration we are going to discuss into the uniformly accelerated motion. One parameter is, right, remaining. Before that, let's move on to, let's rapidly, let's have the glimpse of what we have discussed till now, right? Okay, see, position we have discussed with the motion. Okay, see, motion, frame of references, right? Okay, the inertial and non-inertial frame of references, sign conventions, right? Position, path length, and displacement. And we are going to discuss, we discuss speed, velocity, the difference, average speed, average velocity, instantaneous speed, instantaneous velocity, right? And after that we moved on to some sums related to it. So all of the fundamentals we have covered. Now we are going to on to the motion. If I'm talking about the motion, then three kind of the motion we are going to discuss in this lecture. First, we are going to discuss about the uniform motion. Second, we are going to discuss the uniformly accelerated motion. And third, non-uniform motion. The maximum sums based on the calculus method will be of the non-uniform motion. Separately, we are not going to discuss this stuff. Hai na? Simple. Uniform motion, it means that speed is constant. Right? Okay, speed is constant. Here, okay, velocity is either increasing, right? Or velocity is at decreasing. Either it is decreasing or increasing, but everything is going on at the uniform rate, or acceleration of the particle is kept constant. Okay. Non-uniform motion, no bharosa. Anything can change at any moment of time, at any time instance. Anything can change at any time instance. Right? How much amount of the time? Yes. I think 1 hour and 20 minutes we have more on. Okay, it's approximately 4 hours of the lecture, but everything we are going to discuss. We moved on to the first most important part, fundamentals we have covered up. Right now we are moving on to the right concepts of the uniform motion. Rapidly we are going to see the sums related to it. After that we'll move on to the graphs, uniformly accelerated motion, and all of those stuff we are going to discuss. Now, uniform motion. As I said, uniform motion, it means what? Speed is constant. This is a summarized form of the uniform motion. A very summarized form. But equal distance in equal time intervals. Equal distance in equal time intervals. That's an exact definition of the uniform motion, right? One visualization is there in front of you all, right? I'm going to show that stuff, okay? I'm going to show that stuff, right? Okay, now this uniform motion can exist between the any 2 points into the motion also, or it can exist before the entire journey also, right? This can be in between any 2 points also, and it can also exist for, right, entire journey also. Any 2 points or entire journey, right? Any 2 points or entire journey. See now how I'm going to, suppose this is t is equal to 0. This car is starting its motion, right? This is the first distance interval x1, right? This is the second distance interval x2. This is the third distance interval x3, right? This is the fourth distance interval x4, and this is the fifth distance interval x5, right? Hope so it is visible for all, right? As of the high visualizations, right, there is a what we can say small lag into its presentation, so I am extremely sorry for that stuff. Okay, here it appears. This is x1, this is x2, this is x3, this is x4, and this is x5. Now, what is an actual concept of the uniform motion? The all between points A, right, and between points A and B, all distances are same in particle is covering the equal distance in equal time intervals, equal distance in equal time intervals, equal distance in equal time intervals, right, in equal time intervals, right. It means that this is also t, this is also t, this is also t, this is also t, and this is also t, and this is also x, 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 x. The particle is said to be in uniform motion. It is possible. It is possible. Okay, let me discuss one another stuff with you all. Suppose particle is moving on from A to B. This is x, this is x, this is 2x, and this is 2x. This is t, this is t, this is 2t, and this is 2t. Again, you can see, right, the motion is uniform. Right? If it is covering the distance x, time is t. It is covering the distance x, time is t. Suppose the distance is of the 2x, then time is 2t. First example. Suppose a particle is moving on from point A to point B, obviously. X, x, 2x, 2x. Suppose it is covering with t, 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 t. No worries. Right? This is also the uniform motion. This is also the uniform motion. But this is with the different average speed v1. This is with the different average speed v2. Right? There is a difference, and this kind of a confusion is always there. Suppose particle is moving on from A to B. First distance interval is of x. Second distance interval is of x. The third one is of 2x, 2x. To cross this x, it is taking the time t. Another x time t. For 2x, it is taking time 2t. So this is a uniform motion. Yes, equal distance, equal time intervals. This is also the uniform motion. For x, t. For x, t. For 2x, it is also t. For 2x, it is also t. But we are having the two uniform motion in this cases. For short period of time, particle is having some different speeds. After that, the speed is getting changed. It doesn't mean speed is increasing or decreasing. No. This doesn't mean speed is increasing. No. It means speed is changing. Value is changing. It is constant. The value is getting changed. It is constant. The value is getting changed. So this is what the uniform motion is, right? Just 2 to 3 equations are there for the uniform motions, right? And this things, right, here we are going to end. Just 2 to 3 cases. Okay. So now let's move on to the most important question solving approach, right? See, speed is constant. Okay. First, we are going to discuss with an average speed, right? The formula of the average speed, most important, used right into the questions of the uniform motion. That is total distance by total time. Suppose particle is moving on from A to B, right? First distance is of d1, second is of d2, dot dn. Time is t1, t2, dot tn. Right now I'm taking the general formula, not moving into that much specific part. So total distance is d1 plus d2 plus dot plus dn, whole divided by total time t1 plus t2 dot plus tn. Sir, we are having the confusion. Why you didn't take all time intervals as equal? As I told you all, I'm writing down the general equation, right? Okay, it is not sure all the time that d1 is equivalent to d2 is equivalent to d3 is equivalent to d, right, 4, and it is equivalent to dn. No, not all the time. Sometimes it might happen that d1 is equivalent to dn, d2 is equivalent to d4, but d1 and d2 are not equal. Then also it is a uniform motion. Speed is changing its value. Not it is it is not uniformly or non-uniformly. For specific time interval, particle is moving with 10 km per hour, right, for 10 seconds. So for 10 seconds it is a uniform, right? Suppose suddenly its value got changed from 10 to 20. So 10 to 20, suddenly it got changed. Now 20 is constant. Now 20 is not rapidly changing to 30. No. Okay. Suppose the distance is not given, right? Then we can write it as V1 T1, V2 T2 plus dot 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 plus Vn Tn, right? Whole divided by T1 plus T2 plus dot 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 plus Tn. Suppose time is not given, right? The same thing we write it as D1 plus D2 plus dot 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 plus Dn whole divided by, right? Okay, D1 by V1 plus D2 by V2 plus dot 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 plus Dn by Vn. Rather than to move on to the so much complex, right, approach, okay, you have to just remember this thing, right? You have to just remember that stuff. Equal distance, right, for whatever time instance it should be, for equal distance, equal time intervals, right, speed is constant, then this kind of the motion, it is the uniform motion. Okay. Okay. So this is the first formula, this is the second formula, and this one is the third formula, right? Now, suppose there are two special cases. Suppose if particle is moving on from point A to point B, two equal distance interval it is covering, x and x. Suppose particle is moving on from point A to point B, the two equal distance, right, interval it is covering, right? Now what will happen? Suppose the first distance is covering with speed v1, second it is v2. So for this interval it is a uniform, for this interval it is a uniform. v1 is changing to v2, value is getting changed and again being constant. Again in next interval the value will get changed and again it will be constant, right? So for the time frame this value is getting constant. That's why we are saying, see, it is not like that v1 is changing v2, v3, v4, v5 rapidly. No. Or in very short interval v2, v3, v4, v5. No. v1 constant. After some time v2 constant. After some time v3 constant. After some time v4 constant. v5 constant. Like this thing is going on. So that's why for this time interval I am saying the particle is performing the uniform motion. For next distance interval, I am saying the particle is performing the uniform motion. That is a very slight difference, right? So this is a special case. It is a special case of equal distance intervals, right? Equal distance intervals. So for this stuff, right, average speed, we are going to have it as, okay, we are going to use this formula because nothing is mentioned about the time, right? So we are going to use the third most important formula, right? So that will be, okay, x plus x whole divided by x moving with velocity v1 and x moving with velocity v2. So if two equal distance intervals are given, we can directly apply the formula of the average speed as this. We can directly apply the formula of the average speed as this, right? Okay. For two equal time intervals, right? Suppose the same situation is given, right? Suppose the same situation is given, right? Particle is moving on from point A to point B. For time t, it is moving on with the speed v1. For time another, right, t, it is moving on with the speed 2. This was for the equal distance interval. This is for the equal time intervals. This is for the equal distance intervals. This is for the equal time intervals, right? So for this, again, average speed we can calculate it as, now distance intervals are not given, so we are going to use this formula, right? So it will be v1 of t plus v2 of t by 2 of t. So it is v1 plus v2 whole divided by 2. So if we are having the case of equal distance intervals, we are going to use this formula. If we are having the case of equal time intervals, right, we are going to use this formula. That's it. This is only what we can say the uniform motion is all about. Apart from this, right, they used to confuse you all by changing the path. right? They used to confuse you all by changing the path. They will give you the semicircular path, right? They will give you the path on the theta basis, right? Okay, just they use in uniform motion, they are going to confuse like that way only, right? So this question was asked into the mains 2011. It is a very simple. Particle covers half of its total distance with speed v1 and rest half with v2. What is an average speed of the complete journey? It's a simple thing. Particle A, B. The same thing we are going on. Okay, this question, same question has been asked in main 2011. Yes, it's easy. From A to B, two equal distance intervals are been distributed. For first x, it is moving with the speed v1. Okay, so it is a case of equal distance intervals. It is the case of equal distance intervals, right? Okay, it is a case of the equal distance intervals. Now for that case, obviously, first of all, I'm going to write the common formula of average speed, right? Okay, what it states total distance, right, by total time. Okay, now how much distance intervals we are having? X. Are we having any kind of the total time? No, we are not having any kind of the total time. So I'm going to replace the time as distance by speed, right? So finally we are going to get it as average speed, right? That will be equivalent to 2v1 v2 whole divided by v1 plus v2, right? The C will be the perfect answer for this specific question. C will be the perfect answer for this specific question. Very simple summons, right? Okay, you can just pause the video. It's not a big deal. A car moves from x to y with the uniform speed vx, right? And from y to z with the speed vy and returns to x speed with vz. An average speed for this round trip will be what? X is equal to y is equal to z. Okay, one hint I am giving you all in front. X is equal to y is equal to z. Now what will be the average speed? So this sum is going to clear all of those concepts, right? So if you want to try, you can just pause the video and try this stuff. If you want to try, okay, you can just pause the video and try this stuff. Okay, moving aside, right, giving you all the 5 seconds, right, to stop this video. Okay, it's 5, 4, 3, 2, 1. That's it. Now we are going to solve this. X, y, right? Okay. Sorry, this will not move on. X will be not equivalent to y, equivalent to z, right? Sorry for this, right? Okay, this is x, this is y, and this is z. Suppose this is value small x, suppose this is small x. And when it returns, right, it covers the distance of 2x, right? When it returns, it covers the distance of 2x. Okay, now suppose this is covered with velocity vx, suppose this is covered with the velocity vy, and the last one that is covering with the velocity, this entire thing it is covering with the velocity vz. So obviously if we need to calculate the average speed, then we are going to use a simple formula, right? We are going to use the simple formula. What? Total distance interval, that is x plus 2x. For x we are having the speed of vx. For another x, we are having the speed of vy. For 2x, we are having the speed of vz. Right? Okay. So it will be 4 whole divided by 1 by v of x, 1 by v of y plus 2 whole divided by v of z. Right? So finally our answer will be 4 vx, vy, vz whole divided by, right, vy, vz plus vx, vz plus 2 vx, vy. This will be our average speed. And that will be the specific answer to this specific question. Just a calculation. Okay, just a calculation with the same concept. But in this case, right, I took more intervals. First, I moved on with the first part, x and x, and then I returned back with a distance of 2x. I returned back with the distance of 2x. Okay, now let's move on to the next question. A bus traveling 1/3 distance with the speed of 10 km per hour, then next 1/3 with the speed of 20 km per hour, and the last 1/3 with the speed of 60 km per hour, then what will be the average speed of the bus? Asked in 1991. First, it was not like mains and advanced, right? It was a common thing, and even the screening tests were also there. If I'm talking about this 90s and right zeros, okay. So now, if you want to solve this sum, you can just pause the video. I'm giving you all the 5 seconds. You can just pause it, right? And after that, we are going to see the solution for this. So 5, 4, 3, 2, 1. That's it. A bus traveling, see, the entire journey. Let us take an example. A bus is traveling from A to B. Entire journey is covered up into the 3 parts, d by 3, d by 3 and d by 3. Okay. The first, it is covering with the speed of 10 km per hour, right? Then it is moving on with the 20, and second it is moving on with the 60. What will be its average speed? Simple. D by 3, d by 3, d by 3. First d by 3, it is moving on with the 10. Second d by 3, it is moving on with 20. Third d by 3, it is moving on with 60. Right? D by 3 will get cancelled. Then we are going to have average speed that will be equivalent to 3 whole divided by 1 by 10, 1 by 20, 1 by 60. Right, now we need to just take on the LCM. 1 by 10. Suppose if we are taking 10 as the common, right? If we are taking 10, right, common, so it will be okay, 3 into 10. Okay, 1 plus half plus 1 by 6, right? So average speed V will be 30 whole divided by 3 by 2 plus 1 by 6, right? This will be 2 into 3. LCM we need to take. Okay, 9 plus 1. So 30 whole divided by, okay, will be 6, right? The average speed will be 18 km per hour. C will be the perfect answer. Okay, average speed will be 18 km per hour. Okay. For 3, we are having the specific formula also, but I don't want you all to be so complex in this question, right? Because these things are quite simple and we need to use one simple formula, not more than that. Okay. Car moves with the distance of 200 meter. It covers half of the distance at 40 km. A, B. Half of the distance with the 40 km, right? And second half of the distance with V. Average speed is given. Equal distance intervals are there, x and x. Average speed, right, it is given as how much, right? 48 km per hour. Okay, we have to just calculate the value of V. So this is a very simple thing asked in 1991, and I'm giving you all the homework, right? You can just answer this stuff, right? Okay, beneath the video. You can answer this stuff right beneath the video, right? You can just answer right into the comment box beneath the video. Okay. Now, one nice question. This is asked, right? Because till now, who is seeing this lecture, the student might get bored. Sir, what a simple things are going on. So as I said, now slowly, we are going to build up the foundations, right? If I'm not, suppose if I'm not taking much amount of the time and discussing average speed, average velocity, speed, distance, velocity, right? Okay, then obviously, right, the next part of the chapter, you are definitely going to get confused. Suppose particle is moving on from A to B. What is the path? A to C, C to O, O to D, D to B. This is the path particle is following. Whenever it is moving with the circular path, now it is moving with the pi v velocity. And whenever it is moving onto the straight line, now it is moving with the v. Whenever it is moving into the circular path, it is moving with pi v meter per second. Pi v meter per second, and this is v meter per second. What is an average speed? Okay, this kind of the questions are also asked, and this is a very nice question, right? Okay, average speed, that will be equivalent to first distance interval AC, right? CO, OD, DB whole divided by all times are equal T, right? All times you can consider it as an equal, right? And for each time interval, let us take an example. T is equal to 1 second. Okay, so it will be 4. Okay, for AC, what will be the distance? Suppose if time interval, suppose time interval is not given. Okay, then we can even solve this stuff, right? Okay, suppose first distance interval is what? Pi, right? R by 2. Second distance interval is R. Third is R. Fourth one is pi r by 2. For pi r by 2, it is moving with velocity pi v. For r, it is moving with velocity v. For another r, it is moving with velocity v. For another pi r, it is moving with velocity, right? So this all are distance interval. This all are distance by velocity ratio intervals, right? So in this way you can solve this sum. In many of the right coaching institutes and many of the test series, right, this type of the questions related to distance and displacement always appears, right? You can solve this. It's a very easy, just mathematical steps are remaining. Okay, you can solve by your own. Okay, this was just an additional information. Okay, so you can have a snap because this thing is not going to include it into the because it's a black screen, it's not going to include it into the notes, right? Now let's move on to the next part. Uniformly accelerated motion. See, till now, according to the classification, we moved on with the uniform motion. Now we are moving forward to the uniformly accelerated motion. Now what it states, right? What does the uniformly accelerated motion states? It states that the acceleration of the particle is constant. Summarized form. In detail, we are going to discuss into the very few minutes of this lecture. In detail, we are going to discuss right into the very few minutes of this lecture. Uniformly accelerated motion. Oh, fast and furious. Awesome examples are you kept in front, na? Anna, awesome example. See, before moving on to the uniformly accelerated motion, we need to discuss some points related to an acceleration. What actually the acceleration is? Time rate of change in velocity. Time rate of change in velocity. In another sense, if I want to simple define acceleration as delta v by delta t. The rate of change of velocity with respect to time is acceleration. The rate of change of velocity with respect to time, it's acceleration. Right? Okay. Now, two important things. Right? Sorry, I'm discussing it here. Suppose this is the direction of acceleration and this is the direction of velocity, or this is the direction of acceleration and this is the direction of the velocity. Both are in same direction. Both are in same direction. Both it means that accelerating increasing the velocity if acceleration and velocity both are into the same direction, it means that this way acceleration is trying to increase, it is increasing the velocity, right? If acceleration is in this direction or velocity is in this direction, right? If acceleration is opposite, right? If acceleration is right in opposite direction of velocity, then right, okay, then acceleration will decrease. If it is increasing the velocity, its name is acceleration. If it is decreasing the velocity, its name is retardation or sometimes deceleration. If it is increasing the speed or if it is increasing the velocity, then it is acceleration. Now the uniformly it is increasing, right? Then acceleration is constant, that we are going to, this is a general thing. This is not related to the uniformly accelerated motion. No guys. Before uniformly accelerated motion, we need a warm up. That thing we are going to, right? That thing we are seeing here right now. Okay. Acceleration in direction of velocity is increasing the velocity, and this thing it is known as acceleration, right? Okay. Acceleration in opposite direction, it is deceleration. Seen the matrix. Right? You have seen na in the teaser. You have seen or not in teaser? Retardation, acceleration, retardation, acceleration. You have seen na matrix. You have seen or not? Teaser. You have seen na? Same thing. Motion under gravity. Okay. So this was the thing. Okay, now assumptions, right? Okay, before moving on to an assumptions, let's move on to the most important thing of the uniformly accelerated motion. See yeah, best visualization, Fast and Furious. You have seen lots of races, right? If you've seen the Formula 1 races also, if you've seen the film, obviously there might be some, right, students, those who are not interested into the Formula 1 races. But obviously maximum number of the students have seen this Fast and Furious film, and this scene you are completely aware of, right? It is the beginning of the race, right? Okay, Tornado, it is trying to accelerate. Initially the car is at rest, suddenly accelerating, the velocity is increasing with respect to time. Tornado, initially it is at rest. He was like waiting for a signal to begin the race. Suddenly velocity was increasing and uniformly rate. That's an acceleration. And this kind of the motion, it is known as uniformly accelerated motion. The acceleration of the particle is completely kept constant, or velocity is changing at a uniform rate. Now what it states, uniform rate means what, right? Velocity is not changing like uneven form, it is changing uniformly. Come on yaar, eraser be appear in front na, as because of this visualization there is a lag. Hello eraser baba, please come, I've already clicked. Hello eraser baba. Hey man, see. Hello, now it came. Okay. So uniform rate. Suppose what this word actually mean. Velocity is changing at the uniform rate. Supposing first 5 seconds. Tornado is starting first 5 seconds. Velocity changes by 5. In another 5 seconds it is changing by 5. In another 5 seconds it is changing by 5. In another 5 seconds it is changing by 5. So 0, 5, 10, 15, 20. Right? At uniform rate it is increasing or decreasing. 20, 15, 10, 5, 0. 0, 5, 10, 15, 20. 0, 5, 10, 15, 20. Uniform rate increasing. 20, 15, 10, 5, 0. Uniformly decreasing. And it stops. Rest. Starting from rest to 20. Increasing. Decreasing from 20. Rest. In this uniform matter, it is increasing or decreasing. And that's why it is specified as a uniformly accelerated motion, right, in which acceleration of the particle is kept constant, right? Either it can be positive, either it can be negative. And as usual, two most important point, right, acceleration and velocity, if they are in same direction, right, then acceleration is positive. Okay, if acceleration and velocity, they both are in different direction, right, it is known as deceleration, and acceleration is negative. This is going to speed up the particle, this is going to speed down the particle, right? This is going to speed up the particle. If acceleration and velocity are in the same direction, right, okay, the particle is going to get speed up, right? The visualization is there in front. Okay, if they are in different direction, then particle is going to get speed down. The second example, the best example for this second concept is while applying the brakes, right? One retardation is produced that will oppose the motion of the particle, right? And the natural brake of a girls when they used to, right? Sorry girls, I'm extremely sorry giving all this example in front of you all. I'm extremely sorry, but girls, you are not having any kind of the brakes, right, in your vehicles. You are having a natural brake in your legs. Whenever you used to drive, now suddenly any obstacle appears, now you never apply this brakes, right? You will apply the legs like this way. Suppose if you are moving like this way and suddenly an obstacle appears, oh, Pani Puri Wala, right? Suddenly obstacle came, now, oh, Pani Puri Wala. So you are not going to press these levers, right? You're going to press your natural brakes. Your disc brakes, legs, right? You are going to just, what we can say, you can create a friction between legs and your roads, right? So that's a uniformly accelerated motion. The acceleration of the particle is kept constant, right? See, there are some assumptions. First, in this motion, air resistance is neglected. Generally, in maximum cases, air resistance is neglected, but there exist some cases in which air resistance is considered. In maximum cases, we are assuming air resistance is neglected, particle is never thrown or can attain speed more than escape speed of the earth. This concept, right, you're going to get into the right chapter of gravitation, right, VE. This thing you're going to get into the gravitation chapter, right? Particle, see, if it is accelerated, right, it can never, right, never have a value equivalent to the escape speed, because in this thing it is going to, right, escape the gravitational field of the earth. And it is never, right, in motion the gravity, it is always thrown less than escape speed, right? Okay, the curvature of earth is not going to, right, the earth factors are not going to affect, summarized form. Earth factors are not going to affect the stuff. Air resistance is avoided, right? Particle is never thrown, right, less than escape speed, or see, it is never thrown less than escape speed, right? It is never, this one here, factors not going to affect. Earth factors are not going to affect. Air resistance is neglected. So these assumptions we are going to take. Okay, now classification: uniformly accelerated motion and motion under gravity. Right, but before that, let's move on to the two important methods, right? Let's move on to the two important methods of the uniformly accelerated motion, right? What are those two important methods, right? Let's see this thing. Okay, first, it is a general equation of the uniform accelerated motion where acceleration is kept constant, right? We have derived this equation, right, using this graph. Okay, suppose this is u, right? This is v. Okay, this is happening. The velocity of the particle, see, at t is equal to 0, the particle is having the initial velocity of u. At after some time t, the particle is having v, right? So this is the vt graph, right? So for this kind of the derivation you have seen into the NCRTs, we are having the three equations for the uniformly accelerated motion. First, v is equal to u plus at. This shows how velocity changes with respect to time. Second, s is equal to ut plus half at square. How displacement is changing, particle displacement is changing, right, with respect to time. Right, and the third equation, v square minus u square, right? These all are applicable when acceleration of the particle is kept constant. These are the three equations of the uniformly accelerated motion. All of the things you have already seen into the regular lectures, right? We are interested in what kind of the sums they are asking as a PYQ, right? What kind of the sums? So first, acceleration is kept constant, right, and up to some specific time. Okay, so this is one actual method. Now there comes another method, right, that is known as calculus method, that is also mentioned into the NCRT book, and that is the calculus method. Right, now what it states, right, what does the calculus method say? See, calculus method is applicable for the uniformly accelerated motion also and for non-uniform motion also. It is applicable for both. For uniformly accelerated, this is applicable, calculus method is applicable for all. Right? It is having only three equations. How velocity is changing with respect to, or how velocity depends on displacement, it is by this equation. How acceleration is going to depend on velocity, it is by this equation. This is also known as instantaneous acceleration. And how acceleration is going to depend on velocity and displacement. So this is the third equation. So these are the only three equations of the calculus method, and maximum these equations we are going to use in graph and then conversions. We are going to use these equations in graph and then conversions. Right, so these are the two methods for the uniformly accelerated motion. Right, first one, it is in a general method, sometimes it is also known as graphical method, from which the three equations of the motions are arrived. If you want to derive this three equation of the motion from calculus method, right, we can also do that. Right, a is equal to v dv by dx. Suppose a is equal to dv by dt. This equation of the calculus method I am going to take. So dv, that will be equivalent to a dt, integrating both sides. Particle velocity is changing from u to v, it is changing from 0 to t. V minus u is equal to a of t. So here comes the first equation of motion we derived from the calculus method. Right? Second, if I'm going to use v is equal to dx by dt, right? So dx is equal to v dt. I'm going to replace the equation here. It will be u plus at, right, dt and dx. I'm going to integrate on both sides. So this will be x minus x0 is equal to ut plus half at square. So this is the second equation of the motion that we got from this, right? The calculus method. And third, a is equal to v dv by dx. Again, right, the third equation we are going to get from this, right? So that's why this is a derivation proof, right, of the calculus method and how the equations of the uniformly accelerated motions are derived using the calculus methods. This is nothing else but an instantaneous velocity. This is nothing else but an instantaneous acceleration. This is nothing else but another equation of the instantaneous acceleration, right? Dx is just a small displacement, right? Dx is the very, very small displacement, right? So that concept of the instantaneous in position is for calculus method only, right? If you want to just take a snap, you can just have it giving you all the 5 seconds. 5, 4, 3, 2, 1. So for this reason I've written this calculus method is applicable for all. It is applicable for the uniformly accelerated motion also, for non-uniform motion also, because all of those equations, right, we can derive using this calculus method. And obviously I want to tell you all, for NEET and JEE, this is more important. Okay, you all are aware of these equations, thousands of sums you have solved related to this. Most important is calculus method. Right. So now this was the classification of the two methods of the uniformly accelerated motion. I want to just have a glimpse of it. Uniformly accelerated motion, it means acceleration is constant, velocity is changing, either increasing or decreasing, but at the uniform rate. Okay, acceleration in same direction of velocity, it is positive. Acceleration, it is opposite direction, it is going to speed down, and it is deceleration. We have seen the assumptions and two most important methods. What will be the question solving approach? Okay, 6 formulas. For question solving approach, it will be v is equal to u plus at. Second, right, s is equal to ut plus half at square. Right. Third, 2as. Right, v is equal to dx by dt. The fourth important formula. The fifth important formula, a is equal to dv by dt. The sixth important formula, a is equal to v dv by dx. For question solving approach, these 6 important formulas we are going to use, right, and we are going to solve these questions, right? We are going to solve these questions. Now let's move on to the first question, right? Okay, now see, first we moved on to the distance, displacement, path length. We saw the sums related to it and some of the PYQs. Then we moved on to the concept of speed, velocity, average speed, average velocity. We saw the differences between them and we solved the sums related to it. After that, we moved on to the sum of the fundamental concepts of the uniform motion and we solved some sums related to it, and those were PYQs. Now we have seen the concept of the uniformly accelerated motion. We are going to solve some sums related to it. After this, we are going to see some of the concepts independently related to graph, and we're going to solve some sums related to it. After that, we are going to discuss some of the concepts of the motion under gravity. We are going to discuss some sums related to it. After that, we are going to discuss some concepts related to the motion under gravity, and we are going to discuss with sums related. Relative motion and sums related. Right? So this is the first question appearing in front of you all, guys. I'm giving you a pause. You can just read this question. You can pause the video and solve it. I'm moving aside, right? And immediately we are going to solve this stuff. Come on, everyone. Okay, I'm giving you 2 seconds to pause the video, right? The question states, let's see. Okay, so till now we have seen that uniformly accelerated motion, and give you the time to pause the video. Now let's move on. See, a particle, right, starts from its motion from rest under the action of the constant force if the distance covered into the first 10 seconds is s1 and that covered in first 20 seconds is s2. See, generally right? We are not taking any consideration, right, for forces. We are not having any kind of the consideration for forces. But the simple thing is that, okay, you all are aware the definition. You are all are aware of the definition of forces. That is F is equal to ma, A is equal to F by m. Mass is already constant. If force is given as a constant, it means that acceleration of the system is constant. Bingo. Acceleration of the system is constant. It means that yes, we can apply the equations of the uniformly accelerated motion. We can apply the equations of the uniformly accelerated motion. Now what it states, right? For first 10 seconds, see, it starts from rest. Let us take an example. At t is equal to 0, this will be our reference point from which object like particle starts its motion. It is from rest. It means initial velocity is 0. At t is equal to 0, u is equal to 0. First 10 seconds. Right? The distance covered is s1. What will be the total distance covered into 20 seconds? s2. So what will be the relation between s1 and s2? Right? What will be the final velocity after 10 seconds? We are not aware of. What will be the velocity after 20 seconds? We are not aware of. Right? We are having just one data. That is about the time interval, and second information, that acceleration is constant. See, if acceleration of the particle is kept constant, right? If acceleration of the particle is kept constant, it means this, we can use this equations. Right? Now we need to find the relation between S1 and S2. See, it is important. Till now, all of those sums that came in front were easy. Quite easy. It was not a big deal. But here, right, we need to think of whatever amount of the data is given, how you can see. One question will always arise in your mind of, right, all of the students. How you can solve all of the numericals of the physics into the very small amount of the time. Or in another sense, how you can solve all of these questions rapidly. Right. So for that, I want to tell you, right, just the first step is, right, just write down all of the data, whatever it is given into the question. Right. Try to figure out what is asked and always try to make up, right, to find a way. Always try to find a way, whatever the data is given, or you can make a bridge from whatever the data is given and what we need to find out. Always make a connection. Try to make a connection. This is only a way you can solve all of those stuff, right, rapidly. All of those numericals rapidly. So what is the data given? The time interval is given, right? Displacement information is given, and another thing is given, acceleration is constant. See, in options, you can see we need to find the relation of the displacement. So it means one thing we are having fixed, right? We need to use the second equation, because second equation is only the equation that shows the relation between displacement and time. Second equation is only equation that shows the relation between the displacement and time. So it means that S is equal to ut plus half at square we are going to use. S is equal to ut plus half at square we are going to use. Now initial velocity is constant, so displacement will be half at square. This will be our equations, and that we are going to use with the sign conventions. Right, for first 10 seconds, see, the equations are always applied with respect to the reference point. Here t is equal to 0 will be our reference point, right? They are always applied. Okay, so for first 10 seconds, can I say S1 that will be equivalent to half A, right, in 10 seconds, right? So S1 will be equivalent to 50A. Can I consider this as equation number 1? Yes, I can consider this stuff as equation number 1. Now, with respect to reference point in first 10 seconds, 58 displacement is going on. 58 displacement particle takes place. Right. Now, what about with respect to the t is equal to 0? Right. In the next 10 seconds. In next 10 seconds, right, it means that with respect to the reference point, total 20 seconds we are talking about, right? So with respect to t is equal to 0, right, S2 that will be is equal to half a T2 square. What will be the value of T2? This will be with respect to T is equal to 0, right? T2 that will be equivalent to 20 seconds, right? T2 will be equivalent to 20 seconds. So it will be half a 400, S2 that will be 200 a, right? If you are replacing this equation in S2 that will be equivalent to 4S1. S2 that will be equivalent to 4S1, right? S2 that will be equivalent to 4S1. So here we found the relation between S1 and S2, right? B is the perfect answer for this specific question, right? B is the perfect answer for this specific question, right? So this was the use of the first equation. Now let's move on. This question has been asked in 2009, right? Now the most important thing we discussed, right? Okay, the displacement in nth second, right? Now that concept I'm going to show you in front, right? The derivation of displacement of nth second. Suppose, let us take an example. The particle at t is equal to 0, it starts its motion. This is my reference point, right? In another sense, you can say observer is standing at this position. As I said you all, motion without a reference point, it means it's nothing, right? So t is equal to 0, it is my reference point. It is right, a point where observer is standing, right? Inertial frame. Now particle is moving on for n seconds, right? So this equation is for, right, what is the distance that particle is going to travel in nth second, right? So in another sense, it means that we need to calculate this much amount of the, can I write it as Sn? Yes. The Sn is distance to see. I'm writing here Sn, that is distance traveled in nth second, right? Distance traveled in nth second. Okay, now let's move on to the derivation. Okay, see, with respect to the reference point, can I say, suppose this is n second, so this will be n minus 1 second. So Sn, the distance traveled in nth second, will be S of n1 minus S of n minus 1. Right, the total distance, right, for nth seconds, this will be S of 1 minus the distance traveled into n minus 1 second, right? If we are going to subtract this part from the entire, we are going to get the displacement in nth second. Again, I am repeating, if we are going to subtract the distance traveled in n minus 1 second from the distance in nth second, then we are going to get the displacement in nth second. This is displacement of n seconds. There is a difference. Displacement of n seconds. Displacement in nth second. Displacement n seconds. Displacement in nth second. Ut plus half an square minus, sorry, un, because it's for n, un minus 1 plus half a of n minus 1 square, right? N minus 1 square. I'm sorry. Okay, n minus 1 square. Okay. Oh man. Okay, no worries, right? It was a black screen, right? No worries. Okay. Okay, no worries. No worries, right? We are going to see that stuff. Okay, no worries. Right, so it was S of n, that is S of n minus n1, right, minus S of n minus 1. So it is S of n, that is equal to U of n, right, plus half a of n square minus U of n minus 1 plus half of, right, a of n minus 1 square, right? So solving this, the displacement in nth second, we are getting U plus a by 2 of 2n minus 1. Right, so this is the equation of displacement in nth seconds, right? Displacement in nth second. Okay, displacement in nth second, and this equation we are going to use into the next sum. Okay, so now the distance traveled by a particle starting from rest moving with acceleration 4 meter per second square. See, acceleration is given as 4 by 3 meter per second square, right? And what will be the displacement in third second? We are not talking about the displacement in 3 seconds. That is the difference, as I said before, right? Displacement in 3 seconds differs from displacement in third second. So here we need to calculate the displacement in third seconds, right? So again, guys, it's a very simple thing. What the data is given, right? Okay, we need to just evaluate the answer, right? So data is given, acceleration is given. Now here, what we need to find out? We need to find out the displacement in third second. So immediately by reading this grammatical word, this statement, right? By reading this statement, immediately you will get a click. Now we need to use this equation of displacement of nth second, right? We need to use this equation of displacement of nth second, right? So again, I'm giving you all, you can pause the video, right? You can just, solve this. Okay, and we are going to start. So 5, 4, 3, 2, 1. Right, okay, see now. We are directly going to use displacement for the third second, that is u plus a by 2 into 2 of n, right, minus 1. Okay, see, starting from rest, u0. Acceleration is 4 by 3, right? What is a third second? Third second, it means 2 into 3 minus 1, right? So what will be the displacement? It will be, right, 2 by 3, right, into 3 to the 6 minus 1, right, 5. So it's 10 by 3 meter, right? The displacement in third second, that will be 10 by 3 meter. Okay, now I'm going to show you the difference, right? Okay, suppose S3 ut plus half a t square. U is 0. It is half a of t square, right? So it will be half into 4 by 3 into 9. 3 3s are. With respect to the reference point, t is equal to 0, right? The displacement in 3 seconds is 6 meter. Displacement in first 3 seconds, in 3 seconds 6 meter, but displacement in third second is 10 by 3 meter. That's the difference I want to show in front of you all this, right? There is a difference between nth second and, right, in first 3 second 6 meter, in the last third second 10 by 3, right? Okay, so here 10 by 3, this will be the perfect answer for this specific question. Okay, 10 by 3 is the perfect answer for this specific question. Now let's move on to the next part. The acceleration, it's really a nice example, right? It's really a nice example, right? Okay, see, a car accelerates from rest at a constant rate alpha for some time, after which it's decelerate at the constant rate beta and comes to rest. Starts from rest, accelerates with alpha, decelerates with beta and come to rest. Starts from rest, accelerates to alpha, decelerates to beta, comes to rest. If total time elapsed is t, then maximum velocity acquired by the car will be what? Starts from rest, accelerates by alpha, it reaches to the maximum velocity, again it gets decelerated and reaches to rest. 0, maximum 0, 0, maximum 0, 0, maximum 0. So what will be the maximum velocity attained by the particle? Right? So again, if you really want to pause the video, you can pause it, right? Okay, and I'm moving aside and giving you all the 5 seconds, right, to pause this video. Okay, come on, and I will start solving this sum. Okay, see, 5, 4, 3, 2, 1, that's it. car accelerates. Okay, see. T is equal to 0 will be my reference point. T is equal to 0 will be reference point. At this, it is at rest. It means U is equal to 0. Now it is getting accelerate. Up to time interval T1, it is getting accelerated by alpha. Here we will get the maximum velocity. Initially the velocity was 0, suddenly it get accelerated, right? So velocity changes uniformly from 0 to max, right? After alpha acceleration is applied, the velocity is changing from 0 to max. Velocity is changing from 0 to max, right? Velocity is changing from 0 to max. Now suddenly acceleration alpha changes to, right, deceleration beta. And after time t2 seconds, again it comes to rest. So the final velocity of the particle is 0. At t is equal to 0, it's at rest, suddenly got accelerated, it reaches to the maximum velocity, and again it reaches to the... Suppose if you want to move on to solve this sum through graph, right, then this will be the VT graph, right? T is equal to 0, right? V is equal to 0. It reaches, it is accelerated by alpha, right, till the time t1, and it is decelerated by beta. What will be the total time of the journey? That is t is equal to t1 plus t2, right? Now what we need to calculate? We need to calculate this maximum velocity. See, somewhere by seeing this information immediately, right, you should get a click about the solution of this, right? What should be the click? Velocity, acceleration, and time. This thing is given. It means somewhere, see, whatever the data is given, data is it shows about velocity, acceleration, and time. It means somewhere I need to pick up that equation which shows the relation of velocity, acceleration, and time. For that, I'm going to use the first equation of motion, and obviously acceleration is given as constant, so that's why I'm using this equation. Acceleration is given as constant, so that's why I'm using this equation. Right now, suppose for first time interval t1, can I say the final velocity is Vmax? Initial velocity is 0, right? Between this, okay, between this, t is equal to 0 to t1, I'm applying the first equation of motion. Initial velocity is 0, accelerated by alpha, time is t1. So can I say t1 that is equivalent to Vmax, right, whole divided by alpha. Equation number 1. I'm not just solving the question, I'm showing you why I use that equation. Why? Because physics is all about write why and suppose. As I said in my previous lectures, physics is all about why and suppose. Why I've used that stuff. Now applying the same equation for, suppose this is A, right? Suppose this is B and this is C. So for A to B, I have applied this equation. Now I'm applying the same equation for B to C, right? Can I use B is equal to U plus AT? Now for B to C, initial velocity will be Vmax. Finally, it is coming at rest. So final velocity will be 0. Initial velocity will be Vmax. Now beta is the deceleration. So it will be negative of T2. So what will be T2? That will be Vmax, right, whole divided by beta. Can I consider this as equation number 2? Right? Can I consider this as equation number 2? Yes. Right? Now, what is the total time of the journey? T1 plus T2. So can I say the total time that is equivalent to what? Vmax whole divided by alpha plus Vmax, right, whole divided by beta. So can I say that will be alpha beta whole divided by alpha plus beta into T. This will be the value of the maximum velocity, right? And this will be the perfect answer, right? This will be the value of the maximum velocity, right? Alpha beta whole divided by alpha plus beta into time. Particle starts from rest. See, one single equation can create a revolution. Man, one single equation can create a revolution. You can see this, right? So what will be our answer? The maximum velocity alpha beta whole divided by alpha plus beta, right? Alpha beta whole divided by alpha plus beta. The D is the perfect answer for this specific question. Okay, if you want to take a solution, or if you want to just take a snap, or if you want to write it down, I'm just moving aside for the 5 seconds, right? You can just pause the video and do whatever you want to do. Okay, so 5, 4, 3, 2, 1. That's it. Now let's move on to the next question, right? Only 3 equations, right? Okay. Now see. A particle moves in a straight line with the constant acceleration. See, particle is moving in the straight line with the constant acceleration. First thing is given. Acceleration is constant. Yes. We can use all of those 3 equations. It changes its velocity. See. Velocity is changing from 10 to 20 meter per second while passing through the distance 135 meter, right? When the velocity is changing right from 10 to 20, the particle is covering the distance of 135 meter and time it is taking, right, t seconds. We need to calculate the t now. See, whenever any 2 parameters are given, right? Okay. Now, okay, let's move on. How to use this? How to identify this stuff? How to identify which equation, right, we need to use to get an perfect answer for this. See, acceleration is not given. See, whenever 2 terms are given and one is unknown, okay, there will be, like, always you will get stuck in 2 type of cases. The first one, among 3, velocity, displacement, among 4, velocity, displacement, acceleration and time. Among 4, 3 will be given, you need to calculate the 4th one. It is easy. 2 will be given, you need to calculate the 3rd one. You need to just follow the extra step. Now suppose your displacement is given. Displacement, that will be equivalent to 135 meter. Initial velocity is given 10 meter per second. Final velocity is given 20 meter per second. Right. So first, you can directly use this equation. S is equal to ut plus half at square. But here acceleration is unknown, right? So we directly can't use this equation. So I'm considering this as equation number 1. Now, see, initial velocity is there, final velocity is there, displacement is there. So suppose if I use the 3rd equation of motion, right, then immediately I'm going to get the acceleration, right? So this is 400 minus 100 whole divided by 2 into 135, right? So acceleration will be 300 whole divided by 2 into 135. So acceleration will be 150 whole divided by 135. Now I'm going to replace the value of the acceleration in this equation, right? Okay. So S will be ut plus half at square, or if you want to, okay, or we can use this equation also. V is equal to u plus at, then also, right? It will be 10, that will be a into time t. Time will be 10 into 135 whole divided by 150. So this will be 9 seconds. Using this equation, right? Okay, it will create an it will increase. Sum would be quite complex, right? So rather than using this equation, we can use the first equation of motion and can reach up to the answer, right? We can use the first equation of motion and can reach up to the answer. So here the 9 seconds is the perfect answer for this specific question, right? 9 seconds is the perfect answer for this specific question, right? You can see now how data is given, how 2 parameters are giving, and we are reaching to the next 2. Among 4, if 3 are given, 3 is given, then we can easily calculate the 4th one. But when 2 are given, right, we need to calculate, right? Okay, we need to reach to the 3rd one, then it's difficult. If 3 is given, we can directly use the any equation among 3 and can reach up to the answer. But if 2 parameters are given and we need to evaluate another 2, then we need a intermediate equation. You can see in a first equation, first I used that equation and then reached up to the answer, right? So this kind of the stuff is there. Okay, I'm moving aside. If those who want to note it down, just note it down, right? I'm giving you all of 5 seconds. Okay, so it's 5, 4, 3, 2, 1. A body starts from rest. What is the distance traveled by body during 4th and the 3rd second? Ratio of particle starts from rest. Can I say t is equal to 0 is a reference point, u is equal to 0 from which the particle can start its motion. Ratio of the distance traveled. This will be the 3rd second, this will be the 4th second. Ratio of distance traveled. So 3rd second starts after completion of second. 0 to 1, 1 second. 1 to 2, second. 2 to 3, 3rd second. So this is our 3rd second. And after 3, 4th second starts. After 2, 3rd second starts. After 3, 4th second start. It means we need to calculate S4 by S3. Yeah. Okay, first of all, I'm moving aside. I'm giving you all the 5 seconds to solve this stuff. Right? You can just pause the video and I'm coming back with the solution. Right? So it's 5, 4, 3, 2, 1. Hope so. Those who have solved, they have paused the video. Now, yeah, immediately by using this term, by seeing this term, immediately you all should get clicked that we need to use the equation of the displacement of nth second. Right? Displacement of nth second, right? Okay, now what's that equation? What's that equation? See, S4 by S3, can I say it is u plus a by 2, right? 2 of 4 minus 1. Similarly, u plus a by 2, 2 of 3 minus 1. This is what an equation of the nth second is, right? This is what the equation of nth second is. So can I say S4 by S of 3, that is equivalent to u is 0, right? So 4 minus 2, 8, 7a by 2 whole divided by 5a by 2. A by 2 is going to cancel, right? A by 2 we are going to cancel. So what will be the ratio of the displacement of, right, 4th to 3rd second? That will be 7 by 5, right? First will be the perfect answer for this specific question. First will be the perfect answer for this specific question. Right? First will be the perfect answer for this specific question. It's very easy. Birth year. My birth year, 1993. Okay, it has been asked in my birth year, right? So it is important. Okay, now. So again, I'm moving aside. It's 5. If you want to write it down, you can just pause the video. 5, 4, 3, 2, 1. A particle's move distance. Now here comes, right, the question of calculus method. Till now we have used all of those type of 3 equations, right? Simple sums we saw, right? Simple sums. And see, this champion series, right, is for all those who want to clear their basics, those who want to clear their fundamentals, right? And slowly they want to be a hero from zero. Right, directly kind of move to the terrace, to the top story, right? From first of all, we need to build a foundation. So this lecture is to, right, clear your fundamental concepts and to see like some of the important sums, and then slowly you are moving forward. And this chapter is like that only, not that much difficulty, right? It's not as that much difficult as what you all are thinking. Calculus method and graph conversion, these things are there, but that things also, those stuff also we are going to solve, right? I'm going to give you all the solution for that, right? Now see, a particle moves a distance x in time according to the equation. Now the position, distance is moving, distance of the particle is changing with respect to this equation. what we need to calculate? The acceleration of the particle is proportional to what? Right? The acceleration of the particle is proportional to what? Okay. So again, guys, let's move on. Let's move aside, right, for 5 seconds. So you can pause this video and solve this stuff. Right? Come on. It's 5, 4, 3, 2, 1. See, if dependency of one motion parameter is given with respect to another, distance is changing with respect to time. Dependency is given, na? So by reading this line, immediately it should get clicked. Somewhere the solution is behind the calculus method. Somewhere the solution is behind the calculus method. I'm damn sure. Right? Somewhere the solution is behind the calculus method. Let's see what it is. See, distance to time is given. We need to move on for the acceleration versus. Now here, there is a difference. Okay, we were expecting, see, it's easy to move on from distance to time, right, to acceleration equation. It is easy to move on from displacement to acceleration. But it is difficult, right, to move on, right, to identify the relation of acceleration with velocities and distance. That is the difference. See, first of all, I want to tell you all a simple thing. Displacement, velocity. Suppose if you want to move on from in this manner, na, then you need to do on differentiation. If you want to move on from displacement to velocity, velocity to acceleration, then you have to follow this differentiation. But if you want to move on to the reverse manner, right, then you need to use the integration, but with integration, initial conditions at t is equal to 0 should be given. It is easy to do differentiation to reach acceleration from displacement or distance, but while following the reverse phenomena, it is difficult. Why? We are always need into the initial condition that at t is equal to 0, right, whether the particle is having the velocity or not, at t is equal to 0, right, whether the particle has covered some distance or not, right. So this is the actual funda, right. Calculus, the entire calculus method relies in this, right. Okay, so you can just have a snap of it. 5, 4, 3, 2, 1. So let's differentiate this equation with respect to time. Let's differentiate this equation with respect to time. Can I say dx by dt? So that will be equivalent to t plus 5 whole to the power minus 1, right? So if suppose if I'm differentiating this term, right, I'm using the chain rule, right? So it will be minus 1 t plus 5 whole raised to minus 2 into d by dt of t plus 5. Right, this is what chain rule is all about. We have seen into the basic mathematics lecture and even the concepts of differentiation. So this will be minus 1, right, t plus 5 whole to the power minus 2. So this will be our velocity. But we need to reach to the acceleration, right? So acceleration, this against differentiating with respect to time. Again differentiating this equation with respect to time. What will we get? Right, it's minus 1 minus 2, right, and that is t plus 5 whole to the power minus 3, right, using the chain rule. So what will be the acceleration? That is t plus 5 whole to the power minus 3. If I need to write the acceleration equation in terms of the distance, so can I write acceleration that is equal to t plus 5 whole to the power minus 1 into 3. This is and this is one and the same thing. Why I wrote this down? Because we can easily calculate the, or A is directly proportional to x cube. A is directly proportional to x cube. Any kind of this kind of the option is given or not? Distance square, no. Velocity, okay, no. So it means, right, we are not having any kind of the related option, right, to this now. But we need to convert, we need to show the relation of acceleration with velocity also. So again, I'm rewriting this term, right? A that will be equivalent to t plus phi, right? Okay. So minus 1 whole cube. Again, rewriting this term t plus phi, right? Minus 2 multiplying dividing by 2, multiplying dividing by 2. So A will be velocity whole to the power 3 by 2, or A will be directly proportional to velocity whole to the power 3 by 2. Right? A will be the perfect answer. Right? This question has been asked in 2010, and this is how the calculus method is used. Right? This is how the calculus method is used. Okay. So guys, again I'm moving aside, you know, having the 5 seconds to solve this stuff, right? 5, 4, 3, 2, 1. Particle moving along the x-axis has the acceleration of f. This question is quite important because this has been asked in 2007 paper, right? Okay, this is quite important. This question has been asked in 2007 paper. Okay, particle is moving. See, acceleration is changing. Acceleration of the particle is changing from f is equal to f0, right? 1 minus small t by capital T. This is the equation. See, acceleration is depending on time. Immediately you all should get clicked, right? We need to use the calculus method, right? Okay, see. The particle, right, at t is equal to 0 and the instance when f is equal to 0. Velocity, we need to calculate the velocity in between what instance, right? We are having the time intervals, right? We are having the time intervals. What is the time interval? Between t is equal to 0 and when f will get 0. This is our time interval. See, because from acceleration, if we need to reach the velocity, and just few minutes earlier I told you all about, if we need to move on from displacement to velocity to acceleration, then we need to do differentiation. But when we used to move on from acceleration to velocity, reverse phenomena, we need to carry on, right? For that, initial conditions are always needed, right? Initial conditions are always needed. Okay. Suppose, and for integration we need a limit. The first part of the limit is given t is equal to 0, right? Second part we need to find out. Suppose the equation of the acceleration is f. Okay, first of all, let's give you all a 5 seconds. You can pause this video and you can solve this stuff. Come on. 5, 4, 3, 2, 1. Hope so you have all paused this video. Now let's solve this stuff. The first limit is given. What will be our second limit? F is equal to f0, right? 1 minus small t by capital T. Now we need to, keep this term as 0, right? So we are getting small t is equal to capital T, right? So we need to do the integration. What will be our limits from t is equal to 0 to t is equal to capital T? This will be our limit of integration. Now, suppose equation of the acceleration is given as f is equal to f0 1 minus t by capital T. Can I replace this as dv by dt using the calculus method? Because according to it, acceleration can be defined as dv by dt. Right? So what will be dv? dv that will be equivalent to integration of f0, right? My f0 of dt minus integration of f0 t by t of dt. Okay, limiting from 0 to capital T, 0 to capital T. These are the limits. I replaced it here. Right, so final velocity Vx that will be equivalent to, right, f0 of t minus f0 of t by 2. So velocity at instance will be f0 of t by 2. Right, C is the perfect answer for this specific question. Right, C is the perfect answer for this specific question. Right, okay, I need to just apply the solution to this board because lots of keech voices are coming, right, and lots of scratch voices are coming. Okay, so this is how we can solve this stuff, right? Okay, using the calculus method. Okay, so now again, if you want to note down the solution, moving side for 5 seconds. 5, 4, 3, 2, 1. That's it. The displacement x. That's a nice question. This question asked in Karnataka NEET 2013 examination. The displacement x is given by, okay, see, one equation it is given t that is equivalent to under root of x plus 3, right? This kind of questions also, comes in, right? This is also the another way in the proper use of the calculus method, right? Displacement and time equation is given. We need to calculate the displacement when its velocity is 0. What will be the value of x when velocity will be 0? Nice question, right? So guys, 5 seconds. You can pause the video and solve this. 5, 4, 3, 2, 1. T minus 3. See, displacement versus time is given. Somewhere you should immediately, by seeing this equation, immediately you all should get clicked. Somewhere we need to use the calculus method. Squaring on both sides. We got the equation of displacement with respect to time. Let's differentiate this equation, right, with respect to time. So while differentiating, right, equation of displacement will get velocity, that is 2t minus 6. Now we need to calculate the value of x when velocity is 0. Now at what time velocity will be 0? 2t minus 6. At 3 seconds, right, velocity, right, okay, velocity will be 0. So we need to replace this 3 seconds here. Okay, so to get the displacement, so x will be, right, equivalent to 9 minus 18 plus 9. X will be 0. Displacement will be 0. Second phase of NEET 2016, another question came. Second phase of NEET. See, till now, right, in uniformly accelerated motion I discussed two methods, right? In uniformly accelerated motion I discussed the two methods. The first one was, right, when acceleration is constant and when we are using the three equations of motion, and second was the calculus method, right? After this sum we will have a glimpse of it. Okay, this is also the easy sum. Two cars P and Q start from a point. Displacement of the P depends on the time as AT plus BT square. Consider this is equation number 1. Displacement of Q depends at Ft minus T square. At what time they both will have same velocity? Immediately by seeing this equation you should get clicked. Yes, we need to use that calculus method. In question it is clearly mentioned, NEET question 2016, at what time velocity will be equal? It means somewhere we need to differentiate this equation and compare them to get the time. Let's differentiate this equation, right? Okay, differentiating the first equation. Differentiating equation 1, right, with respect to time. Right, what we'll get velocity of the P as A plus 2BT. Consider this is equation number 3. Right, and now let's differentiate equation 2, right, with respect to time. Right, so we'll have V of Q that will be equivalent to, differentiating this equation will get F minus 2 of T. Consider this as equation number 4. So finally we got the velocity of P and velocity of Q. Now in this question, these both are equal. At what time this will happen? So for this we need to evaluate Vp is equal to Vq, right? Okay, so A plus 2BT that will be equivalent to F minus 2 of T, right? So 2BT plus 2 of T, that is equal to F minus A, right? So 2T will be common, B plus 1, that is F minus A, right? So this will be f minus a whole divided by 2 of b plus 1. At this time, the velocity will be equal. At this time, velocity will be equal. Right? So it's f minus a 2 of b plus 1. D will be the perfect answer for this specific. So that's the perfect use of the calculus method. Right? That's the perfect use of the calculus method. Right? Okay. Now we are moving forward to the graph, but before that, let's move on. Right? Let's have the glimpse, right, of what we have seen, right, into the uniformly accelerated motion. Okay, what we have seen into the uniformly accelerated motion. See, it's a uniformly accelerated motion. Acceleration is constant, right? We have seen this stuff. Okay, just immediately, right, just like we are moving forward and you should have a glimpse of it. Okay, the equation of nth displacement and lots of things we saw, right? Okay. And finally, graphs. As I said before, I haven't discussed the graph, right, with each type of the motion, but we are going to discuss this stuff independently, right? Graph fundamentals after this motion under gravity, and we are going to discuss this relative motion, right? So let's move on to the graph. Okay, see, graphs fundamentals. Basically, right, we are going to deal with some type of graphs. Basically, not more than that. Basically, we are going to use some type of graph. So, graph fundamentals. Equation of line, circle, ellipse, parabola, hyperbola, and inverse relation, right? These things, right, we are in need of. Graph concept, right? See, I'm going to give you what we can say the Brahmastra to solve this kind of questions based on graph, right? Okay, I'm going to give you all, right, graph and graph conversions we are going to see, right? Graph and graph conversions, right, within short period of time we are going to see, right? Okay, see, graph, the entirely graph, right, I'm going to give you the Brahmastra. What is that? With the combination of calculus method and this concepts, graph sums can easily be resolved, right? With the use of calculus method and this concepts, right, graph based sums and graph conversion based sums can easily be resolved, right? If I'm talking about equation of line, this is a simple mathematics. Y is equal to mx plus c, right? This is physical quantity on y-axis. This is physical quantity on x-axis, right? This is intercept and this is slope. For this, the equation appears like this way. If m is positive, this is y, this is x, right? So this is the equation of line, right? Slope can also be defined as theta m, that is equivalent to tan theta, that is equal to slope, right? In this, theta always with respect to positive x-axis. Theta is always calculated with respect to the positive x-axis. This is of the equation of the line. See, whenever in a graph, if equation of line appears, then immediately it should get clicked. Something related to y is equal to mx plus c we are going to use. If intercept is not there, we are having the graph like this way, right? It completely depends on the value of slope and c, right? Slope is positive, slope is negative, intercept is positive, intercept is 0, intercept is negative, right? Everything depends on, right, value of M and C, right? Everything depends on value of C, right? Again, I'm writing this stuff here, right? Everything depends on, right, graph of straight line depends on value of M and C, slope and intercept. C is 0, graph will be different, slope will be positive, graph will be different, C will be negative, right? Slope will be positive, C will be negative, slope will be negative. Lots of stuff are there, lots of stuff, right? So this is a general form I gave in front of you all, right? So this is the first equation of line, right? The most important thing, right, we are going to use in this session. Second, parabola. Two types of parabolas are there, right? Right. This is the physical quantity on y-axis. This is the physical quantity on x-axis. Two types of parabolas are there. One that is making mirror image with respect to y-axis. Second that is making mirror image with respect to x-axis. Suppose if the graph is like this way. See, okay, this and the dotted line, this and the dotted line are mirror image of each other. This and dotted line, this and dotted line, this and dotted line, they are mirror images of each other. Similarly, this is a mirror image with respect to y-axis. Now, mirror image with respect to x-axis. Mirror image with respect to y-axis. Mirror image with respect to x-axis. If, right, a graph is forming the mirror image with respect to y-axis, then square will be of x. Equation of graph will be x square is directly proportional to y. This will help you a lot into the graph conversions, right? Whenever there is a question, right, to identify the correct graph of a motion parameter and curve is there. So immediately you have to just check it out whether the mirror image is forming with respect to y-axis or mirror image is forming with respect to x-axis or not, right? You have to just check it out. So immediately by that, right, stuff, you can easily select the correct graph. Suppose mirror image is forming with respect to y-axis, square of x is done. Suppose mirror image is forming with respect to x-axis, square of y is done. This is the equation of parabola. From line, right, the most important equation we are in need of. From parabola, the most important equations we are in need of. From line, right, the most important equation we are in need of. From parabola, the most important equation we are in need of. Now, okay, apart from this, there is a ellipse and circle. I'm showing you all in front. Ellipse, right? This is the equation of ellipse, right? This is the equation of ellipse, right? A is semi-major axis, B is semi-minor axis. A is semi-major axis, right? And B is semi-minor axis. Semi-major axis, semi-minor axis, right? This is what an equation of the this appears into the very less concepts, right? Like in SHM and something like that, right? Okay. For motion, parabola and this, right, are important. When A will be equivalent to B, if A is equivalent to B, then this ellipse will form a circle, right? Then we are having x square plus y square, that is equal to a square, right? This is the equation of circle where A will be the radius, right? Okay. And finally, if y is inversely proportional to x, right, then we are having, right, this kind of the graph, right? Okay, and if x is inversely proportional to y, then also, right, we are having this kind of the graph, right? So this is what the fundamentals of graph is, and those who are important. First, the equation of line. Second, I told you about the parabola, how mirror image is forming with respect to y-axis, how mirror image is forming with respect to x-axis. The equation of ellipse. In ellipse, if semi-major axis and semi-minor axis are equal, then it is forming the circle. And the equations of hyperbola kind of curve, right? You can just note it down. I'm moving aside, and you are having the 5 seconds, right? You can just pause the video, right? 5, 4, 3, 2, 1. What does we are moving on to the fundamentals, right? I haven't moved on to that much part. We are just moving on to the fundamentals. What does the slope and the area of graph states? It's y, x is x-axis. If you need to calculate the slope, this is theta, right? Slope is always equivalent to tan of theta, that is always equivalent to dy by dx, or that is always equivalent to del y by del x. This is a straight line. For a curve, suppose curve is given, right? If you need to calculate the slope on single point, see, for a curve, we can calculate the slope in two different ways, right? Okay, suppose this is a parabola. If you need to calculate the curve on the single point, you need to draw a tangent, right? Okay, that tangent, right, will give you the slope, right? And that will be tan theta, that will be equivalent to dy by dx, right? This will be, right, small dx, and this will be, right, small dy. I'm sorry, this will be dx and this will be dy. Suppose if the curve is crossing through 2 points, suppose if curve is crossing through 2 points, then you need to calculate, you need to draw the secant, and this secant is needed, right, and this tangent is needed. This will give you the slope of the graph, right? So this will be x2 comma y2, and this will be x1 comma y1, right? For this we can say tan theta, that is equal to y2 minus y1 whole divided by x2 minus x1. So if a curve is crossing through single point, right, okay, we can calculate the slope by dy by dx if it is by drawing a tangent. If the curve is crossing through 2 points, then we need to draw secant, right? We need to draw a secant. So tan theta, that is y2 minus y1, x2 minus, this is the what a slope gives. For any, if y is velocity, if y is displacement, x is time, slope will be velocity. If y is velocity, x is time, slope will be acceleration, right? So anything dy by dx will be slope. It's just about how to calculate the angles or to draw a tangent or a secant. Next part. Area. Like the ratio is slope. Suppose if you need to move on to with y and x, right, for area, right, for area stuff, right, suppose this kind of the graph is given, this is y and this is x-axis, right? Area under graph is y dot x, right? If graph is non-uniform, this is a uniform graph, na? Suppose the graph is not uniform. How to calculate the area? Suppose this is a graph is given, right? This is y-axis and this is x-axis, right? So for that we need to calculate, suppose if you want to calculate, right, the area between x1, right, and x2 for the non-uniform graph, right? Suppose this area you need to calculate, so that area we can calculate it by integration of y dx, in which y, how y depends to x to the power n is always given. in question, right? For a slope, right, this way you can calculate the area. If the graph is uniform, right, easily you can calculate. If the graph is curve kind of thing, then dependency of y to x is always given, right, and we need to evaluate, we need to integrate to calculate the area, right? You can just have snap it. 5 4 3 2 1. So this is what all about the slope and area, right? So this were the fundamentals of the graph, equations of lines and everything. This was about the slope and area of the graph, right? Now let's move on to the graphs of all motion. Basically, right, okay, three kind of motion we have to deal with. First, it is a uniform motion. Second is a uniformly accelerated motion. The third one is what? Right, the non-uniform motion. So first of all, let's move on to the uniform motion. First, what does the uniform motion state? Speed is constant. It means acceleration is 0. Acceleration is 0. So what it states? This will be the distance versus time graph. Either it will appear like this way, right, or either it will appear like this way, right? First. Second, what will be the velocity versus time graph, right? This will be velocity versus time, because velocity can be positive, can be negative, right? This will be velocity versus time graph. What will be the speed versus time graph? It will be always positive, right? Velocity versus time graph can be positive, can be negative. It completely depends on how particle is moving, right? But speed is always positive, right? What is acceleration versus time graph, right? Acceleration versus time graph, nothing, 0. Right? So this all are the graphs of the uniform motion, right? With fundamentals, you are easily able to identify that stuff. Uniformly accelerated motion. V is equal to U plus AT. What is velocity versus time graph? Right? Simply you can see y is equal to mx plus c. Right? This is velocity, this is time. At y we are having velocity, at x we are having time. Slope will be a, right? Initial velocity will be intercept. This is your initial velocity u, it will be intercept, right? Okay, this is theta, slope tan theta, that will be equivalent to a. This is the velocity versus time graph for the uniformly accelerated motion, right? Velocity versus time graph for uniformly accelerated motion. V square minus u square is equal to 2as. V square minus 2 square is equal to 2as. Suppose if you need to plot V square versus S graph. First we saw V versus T, all of xt, Vt, V square S, As, Vs, right? All of the graph we are going to see for uniformly accelerated motion. All of this graph and graph conversions we are going to see. V square minus U square is equal to 2as. V square versus S, again it is following the y is equal to mx plus c. On y we are having change in velocity. Graph is like this way. This is u square. This is v square. This difference is s, right? And this theta. What will be the slope? Slope will be v square minus u square by 2a. Sorry, v square minus u square by s, right? V square minus u square by s, right? So that will be equivalent to 2a, right? So this is what a new thing, v square versus x graph, right? From the second equation of motion. From second equation of motion, we are going to have the, right, the Now, if this is right, okay, let's integrate this term, v is equal to u plus et, then you are going to have, what is x versus t graph, right? See, s is equal to ut plus half at square. First case, if u is equal to 0, can I say s is equal to half at square? Acceleration is constant, s is directly proportional to t square. Remember the equation of parabola. Square is of t. It means mirror image with respect to y-axis is formed. Parabola, square is of t if u is 0. Suppose if u is not 0. Suppose if u is not 0. Second case. The graph will be shift like this way, right? And this will be the value of ut. I'm sorry, the graph will not shift like this way. I'm sorry. Okay, I'm sorry, the graph will shift like this way, right? This will be ut and this will be equation of graph ut plus half at square. If you need to calculate the slope at the single point, draw a tangent. If you need to calculate the slope at the 2 points, draw the secant, right? If you need to calculate the slope at the single point, draw a tangent. If you need to calculate the slope at the 2 points, draw secant, right? Okay. So if u is equal to 0, this graph, if u is not equal to 0, this graph. See, this is the equation of the graph of the uniformly accelerated motion. Now, we have seen Vt graph, it is following the equation of line, right? We have seen V square versus S graph, it is also following the equation of line, right? We see xt graph, it is following the equation of parabola, right? Now, we are going to see the next graph, that is question solving approach, or we are going to see the graph. Acceleration is constant, right? So what is acceleration versus time graph? Obviously, like this way. If acceleration is greater than 0, right? Okay, acceleration versus time, if acceleration is less than 0, right? So this is the acceleration versus time graph for the uniformly accelerated motion. Acceleration versus time graph, right? Okay, this is velocity versus time graph, right? This is v square, right, versus s graph, right? This is s versus displacement versus time graph, right? Apart from this, as graph is there, vs graph is there, lots of graphs are there, right? Suppose if you need to calculate this, right, vs graph, right? Let's move on to the vs graph for this. V versus S graph, right, for the uniformly accelerated motion. We saw na v square minus u square is equal to 2as. If suppose u is equal to 0, right, so can I say v square, right, is equivalent to 2as? V square is directly proportional to s. C, square of y-axis, it means mirror image with respect to x-axis. Square of y-axis, it means mirror with respect to x-axis. This will be v square versus s graph. On y-axis we are having v square, on x-axis we are having s. Like this way you are having as graph also, right, with v square x graph, right? Now we are going to see this into the graph conversions, right? Okay, we are going to see this into the graph conversions, right? So AT graph, VT graph, V square S graph, see ST, VT, AT, V square S, right? And okay, VS. How many graphs we saw? For uniformly accelerated motion, we saw acceleration is constant. ST graph, right? VT graph. Now here velocity is increasing or decreasing, it completely, as I said, in an entire graph, everything depends on slope and intercept and constants, initial conditions. ST graph, VT graph, AT graph we saw, right? Okay, V square S graph we saw, right? And V versus S graph we saw. So this is what the graphs of the right motion. Graph conversions. This is the most important concept, and now we are going to move on to the solutions for this. For graph conversion, I'm directly giving on to C. Okay, the question solving approach. In all of those graph conversion based question, always it is given, right? AS graph is given, select the correct VX graph. VT graph is given, select the correct XT graph. XT graph is given, select the correct AT graph. Right now, suppose in question it is given what XT graph is given, right? Select the correct VT graph, right? VT graph is given, right? Select the correct XT graph, right? Okay. So this is the question of the graph conversion, right? This is what the question of graph conversion is, right? This is what the question of graph conversion is, right? Very simple. But what will be the Brahmastra for this? What will be the question solving approach? Always, right? Low man. Concepts of graphs of straight line, parabola, inverse relation, right? Circle, ellipse, plus calculus method. This is what the Brahmastra of graph conversion is. Using this Brahmastra, we are going to solve questions in today's session, right? Using this Brahmastra, yes, we are going to solve this question in today's session, right? Calculus method plus concepts of, right? We saw the equation of straight line, we saw the parabola, y, right? And slope and area. Using this combination, the sums based on graph conversion, right, can be easily solved. The sum based on graph conversion can be easily solved. So just have this approach in your mind. You can have a snap, right? When the questions based on graph will appear, right, we are going to easily solve all of those stuff, right? The first question came, right? It's distance versus time graph. See, non-uniform motion. We saw the graph. See, first of all, let's move on to the glimpse, right, of what things we have seen related to the graph. Graph fundamental, we saw equation of line, parabola, we have seen the equation of circle, ellipse, right? Y is inversely proportional to x, its intercept, its slope, angle is always calculated with respect to x-axis, all of those stuff, right? Okay, for slope, right, if 1 point from a curve, then tangent, if 2 points, then we need to draw a secant, right? Area, slope is y by x, area if we need to calculate for the uniform, right, a curve, then easily we can calculate for a curve. We need integration of y versus x. These are the graph for the uniform motion. For uniformly accelerated motion, we saw different graphs, right? And final, we saw the graph conversion. This is the solving approach for the graph conversion. Calculus plus concepts of this, right, basics graph. Now let's move on to the first question. The particle shows the distance versus time graph as shown into the figure. The maximum instantaneous velocity of the particle is around. Maximum instantaneous velocity of the particle is around. Okay, so guys, first of all, okay, let's give you all a 5 minute to solve this question, right? Let's give you all a 5 minute to solve this question, right? Okay, and not 5 minutes, guys, sorry, I'm out of mind. You can just pause the video for 5 seconds. I'm moving aside, right? Okay, so it's, you can pause the video. 5, 4, 3, 2, 1. So a particle shows the distance time graph curve as shown into the figure. The maximum instantaneous velocity of the, at what point? See, simple. Okay, we have seen just a minute before, this any slope of a graph, it is right del y by del x, or that is equal to dy by dx always, right? So in this distance versus time graph, the slope we are going to get as a velocity. The first thing, right, the one thing is right fixed. Slope we are going to get it as a velocity, the maximum instantaneous velocity. So let's draw the slope at point A. Theta is 0, right? At A, theta is 0, slope is 0, right? Velocity is 0. At B, let's have theta 1, right? At B, right, we are having theta 1, so slope that will be equivalent to 10 of theta 1, right? So we haven't reached up to any conclusions, right? Now let's move on to C. At C, we are having theta 2, right? At C, slope will be velocity, right? And that will be 10 theta 2. But one thing is confirmed, theta 1 is less than theta 2. Right? It means if theta 1, see, you can see in this graph now, theta 1 is less than theta 2, and obviously D is also, right? Let us take an example, theta 3. Okay, so can we say at D, okay, the angle is theta 3, slope will be 10 of theta 3. Obviously, theta 2 is greater than theta 1, right? And theta 2 is greater than theta 3. And theta 2 is greater than theta 1 also, theta 2 is greater than theta 3 also. So it means that value of 10 theta 2 is more. So it means that value, the slope at C is greatest of all. And what is the slope of distance versus time graph? Velocity. If slope of C is greatest of all, it means velocity at C is greatest of all. The D will be the perfect answer for this specific question, right? Same. The displacement of a moving particle is shown. Instantaneous velocity of the particle is negative at displacement versus time graph. One thing we are sure of, right? The slope will give the velocity, right? The slope will give the velocity. Displacement versus time graph, and that will be equivalent to 10 theta. Again, we have to plot at C. Theta is acute. Can I say theta 1? It will be acute, right? Theta 1, that will be acute, right? At D, theta 2 is 0. At E, see, theta is always calculated with respect to positive x-axis, right? So at E, theta 4. Can I say this is theta 4, right? Because angle we need to calculate with respect to positive x-axis in anti-clockwise direction. This will be theta 4. So at E, theta 4 is obtuse. It means that, right, slope that is equal to 10 of theta 4. If theta 4 is obtuse, then slope we are going to get as negative value. It means velocity will be negative because slope of displacement versus time graph, right, is velocity. So at E, we are getting negative slope. It means 10 theta value will be negative, and it means velocity will be negative. Instantaneous velocity will be negative, right? Instantaneous velocity will be negative. So this is how the graph based questions are solved. Which of the following curve does not represent the motion in one dimensions? 1992. Which of the, right, the following curve does not represent the motion in one dimension, right? I'm moving aside, you are having the 5 second, right? Yeah, I need to drink water kindly. Okay, I'm giving all a minute to solve this stuff. Come on, in this first question I'm giving all a minute because I need to drink a water. Okay, less than 40 seconds remaining. Time always move forward, right? So this can't represent a motion, and that is a perfect, right? From whatever you want to start up, right? Our reference point is always t is equal to 0, right? But from like whatever point you want to start, it's not a big deal, but time always move into the forward direction, right? So the cyclic process is not possible, especially when time is involved, right? Cyclic process is not possible, especially when time is involved. Okay, so now this is a perfect answer. Okay, so these are kind of the graph based sums now. Okay, the variation of the velocity versus time graph, it is given. We need to calculate the distance traveled, right? We need to calculate the velocity versus time graph. What will be its area? Simple stuff, na? What will be its area? Area will be distance or displacement. Just check it out whether the graph is uniform or not. If it is non-uniform, we need to do integration. If it is uniform, the answer is easy. Yes, the graph is uniform. We need to calculate the distance. Velocity versus time graph is given. It means we need to calculate the area. So I'm dividing entire thing right into multiple parts. See, this will be A1, this will be A2, this will be A3, and this will be A4. So total area, it is distance, and that will be equivalent to A1 plus A2 plus A3 plus A4, right? Now A1 is a triangle. What will be its area? Half base into altitude. What's the base 1? Altitude is of 20. A2 is a rectangle. What will be its area? 1 into 20. Length into breadth. A3 is again triangle plus, right? A3 is again, right, triangle. Okay, A3 is again triangle plus something. So this triangle, this is 1 and 10, right? So this is half into 1 into 10 plus 1 into 10. This will be the area. This is 1 into 10 and this is half into 1 into 10. And this will be again rectangle 1 into 10. So finally the area will be equivalent to 55 meter, and this is the amount of the distance traveled. Now what a new thing we learned from this? Just keep one thing into the mind. You'll always get confused, right, in between distance and displacement. You always get confused between distance and displacement. Whenever the velocity versus time graph is given, right, you can easily calculate the distance. Why? Because everything you need to take positive. Suppose if velocity time graph moves like this way, right? Okay, then also if this value is negative, right? Okay, and if you are calculating the distance, you also need to take positive. Everything you need to take as a positive. So it is easy to calculate, right, a distance from velocity versus time graph. But while calculating the displacement, you need to take negative as negative only. Okay, small difference. From velocity versus time graph, if you need to calculate distance, take everything positive, right? Even on the lower part of the graph also, if it is there, take it positive, because we need to calculate the distance, right? It is always increasing only. If object is moving, the distance is increasing only, right? Okay, it never decreases. And if you need to calculate if you need to calculate the distance, take everything as a positive. If you need to calculate the displacement, take positive as a positive, negative as negative, whatever it is given, right? So that is a small difference. Okay, so this is all this kind of the graph based sum. Now this is most important, the graph conversion. V versus X graph is given, right? We need to find the A versus X graph. V versus X graph is given. See now, V versus X graph is given. By seeing this, see, this is a question based on the graph conversion, and we are really going to use this Brahmastra. This Brahmastra, right? This, right? Okay, we are going to use this Brahmastra, right? See, y is equal to mx plus c. Immediately, y is equal to mx plus c, right? Intercept, let us take an example. Intercept is v0. On y, it is v. On y-axis, we are having v physical quantity. On x-axis, we are having x, right? Slope will be negative of v0 by x0, right? Negative of v0 by x0. On x-axis, we are having x, plus intercept is v0, right? We obtain the equation of velocity versus x using y is equal to mx plus c. The same we have seen into the fundamentals of the graph. Now, we need to form the AX graph. See, v is equal to negative of v0, right, by x0, right, of x plus v0. Let's differentiate this term with respect to x. We are getting dv by dx, that will be negative of v0 by x0. What will be the equation of acceleration? It will be v dv by dx. What is the equation of v? Mentioned. Equation of v is negative of v0 by x0 of x plus v0, right? What is dv by dx? That is negative v0 by x0. From this, we are going to see, using the calculus method, equation of line, right? We are converting the graph. Using the calculus method and equation of line, right? We are converting the graph, right? So what we are getting, equation of acceleration as v0 square by x0 square of x plus v0 square by x0. Now this will be negative. I'm sorry. See, again it is forming the equation of line y mx plus c. You can see now this, what is the equation? A is equal to v0 square by x0 square of x, right, minus v0 square by x of 0. Can I write it as y is equal to mx plus c? Right? On y-axis, we are having acceleration. Yes, we are having. On x-axis, we are having displacement. Yes. This is the slope, and slope is positive. See, slope is positive, but intercept is negative. Select the correct graph from y is equal to mx plus c, in which slope is positive and intercept is negative. Okay, this will not be the answer. Intercept is negative, but slope, see, theta is obtuse. Intercept is also negative, slope is also negative. No. Slope is negative, intercept is positive. No. This is only the answer in which intercept is negative, slope is positive. Intercept is negative, slope is positive. The C is the perfect answer for this specific question. Intercept is negative, slope is positive. C is the perfect answer. This is how the questions are resolved using the equation of line, right, and calculus method. This is how the graphs are converted. Right. If anybody, right, this is a homework from my side. Okay, you can answer beneath the video, because still I think right? 3 hours 45 minutes approximately we have crossed. How much time? Yes, 3 hours 40 minutes has been crossed, right? And we need to discuss the motion under gravity and relative motion. Okay, so this is a homework from my side. If you are not really aware of what we got, we use the Brahmastra. You can see this question again by rewinding this video once. Now let's move on to the motion under gravity. There is a slight difference between, right, the motion under gravity and uniformly accelerated motion. What does the Galileo stated? Galileo stated that, right, whenever the object is thrown, okay, he conducted one, what was the Tower of Pisa experiment, right? It's very famous experiment, the Leaning Tower of Pisa, right? A famous experiment, right? Okay, he stated that whenever the two object air resistance is completely avoided. If air resistance is completely avoided and irrespective of any masses, if two particles are thrown from a height under constant acceleration, right, from a, eraser. As because of this visualization, right, this eraser is creating a chaos, right? Okay, high visuals are there, right? And I think the presentation is unable to load it because this visualizations are must for you all, right? Irrespective of any masses, if two particles are dropped from a height, then they are accelerated under the constant acceleration g, right? Okay, and that acceleration is written as g, the gravitational acceleration of the earth, right? And generally the value of the g is taken as 9.8 meter per second square, right? Okay, I'm reframing this statement, just hold on. Just hold on, right? Just hold on, guys. I'm writing it again, right? Irrespective of masses, if two particles are dropped from a height, then they are accelerated under constant acceleration. And that is gravitational acceleration of Earth g, and that value, right, is 9.8 meter per second square. Right, its value is 9.8 meter per second square. He said it, right, irrespective of masses, right, air resistance, right, is completely avoided. Air resistance is completely avoided, right? Air resistance is completely avoided irrespective of their masses. If two particles are thrown, right, from the dropped from the height h, right, okay, if dropped from the height h, right, then they are accelerated, right, with a constant acceleration towards the center of the earth, and that acceleration is g. Can I say acceleration g is constant? It is always acting into the downward direction according to the sign convention, right? Even you can take downward as a positive also, but for my sessions, right, I'm taking, right, our general conventions, what we have discussed into the, right, beginning of the session. Okay, G is constant. It means concept of the uniformly accelerated motion we can apply. G will be always negative, right? And we are going to apply the sign conventions with respect to what? Right, reference point. What will be the question solving approach? Suppose first case, right? Suppose first case. Okay. Three equations of the motion. V is equal to U minus GT. G is acting into the constant acceleration. It means we can use the three equations of the motion. So first equation we are going to use by this way. S is equal to ut minus half gt square. And third equation v square minus u square is negative of 2gs. Right, this three equation where acceleration is constant, right, and that will be is equal to negative of g. Right, for accurate, for easy, for what we can say, right, convenient and easy calculations, we are going to use acceleration as 10 meter per second square. Generally it is 9.8, right? Okay, but what about sign conventions and how to apply the equations, right? That is an important. So for that I'm showing you all some examples. Suppose this is height h, right? Particle is dropped. Dropped means u is 0. This is the reference point, t is equal to 0. See, with respect to the reference point, this will be the origin, right? You need to apply the sign conventions. Suppose t is equal to 0, u is equal to 0. First equation, v is equal to u minus gt. G will be always negative into the downward direction. Now, u is 0, but while striking the ground, v will be again into the downward direction only. So here v will be negative. So our first equation of motion will be v is equal to gt if particle is dropped from the height h. Okay, these examples I am showing you in front, right, for how to apply the conventions, right? These examples I am showing you in front, right, for how to apply the conventions. Okay, now suppose from ground particle is thrown upward with the velocity u, right? Okay, for this, how to write the second equation of motion, right? See, s is equal to u of t negative of half gt square. With respect to reference point, displacement is in downward, negative. Negative of h, u is 0, negative of half gt square. H is equal to half gt square. This is the second equation of motion. How to write the third equation of motion between first and second interval? V square minus u square, negative of 2gs. With respect to reference point, s negative. With respect to reference point, final velocity, downward direction, negative. So v square is negative of 2g of negative s. V square is equal to 2gs. This is how we are going to write the third equation. Right, these are some of the examples how to apply the sign conventions for this specific topic. Second, suppose from ground, right? Suppose from ground, right? Particle is thrown upwards. With initial velocity u. How to see? It will go like this way. It will reach to the max height and it is going to come down. First equation of motion, v is equal to u minus g of t. U is in upward direction. See, this is our reference point, t is equal to 0. Reference point can be two things. Either t is equal to 0, either v is equal to 0. Right? Okay, with respect to this two reference point, you can apply the equation, not more than that. Right? With respect to this reference point, you can apply the equation, not more than that. V will be 0. So this will be 0 is equal to u minus of gt. T will be u by g. Right? This will be time to reach max height. Time of flight 2u by g. What will be the second equation of motion? Max height will be h na, and with respect to reference point h is positive. So h is positive, u is positive, half gt square. This will be the second equation of motion, right? Okay, this will be the second equation of motion, right? How to represent the third equation? Here it is u, here it is, say v square minus u square is equal to negative of 2gs, right? V will be 0, so negative of u square is negative of 2gs, u square is equal to 2g of s. So s will be u square by 2g. This will be the equation of max height, right? Okay. Max height, time of flight, time to reach maximum height, and this is how the conventions are applied with respect to the reference point. There can be only two reference points, right? First, either t is equal to 0. Second, right, at max height, only two reference points we can take. One, the point of projection, and second, the max height, right? Okay. Apart from this, right, you can apply the conventions between any 2 points, right? Even you can apply the conventions between any 2 points, but among those 2 points, one should be either point of projection, right? You can apply these equations, right, between any 2 points on the path, but among them, right, at least, right, to ease the calculation and for the convenient purpose, right, one should be point of projection of the maximum height, right? Right. So let's see, if you want to take a snap of this, right, these are some of the examples, right? Okay, these are some of the examples. Okay, now let's move on to this stuff. Come on everyone. So giving you all the 5 seconds. 5, 4, 3, 2, 1. A boy standing at the top of the tower, 20-meter height, drops a stone, assuming that g is equal to velocity with which hits the ground. This is ground. This is point of projection. I am saying it as POP, right? Okay, a stone is dropped. Initial velocity is 0. Height of the tower is what? 20 meter. With what velocity it will strike the ground? Obviously, right, we are going to use the first equation. You want to use the first equation. Okay, let's use the third equation. V square minus u square is negative of 2gs. Now let's apply the sign convention. See, this is a point of projection, t is equal to 0, right? With respect to this, we are applying the sign conventions. All the displacement that is taking on with respect to point of projection, all the negative displacement is going on. So final v square, initial velocity is 0, negative of 2g into negative of s, right? So v square is the velocity with which it will hit the ground, that is 2gs. So v square is equal to 2 into 10 into 20. So v square, that is equal to 400. V is equal to 20 meter per second. It was dropped from the height 20 meter with initial velocity 0. It will hit the ground with 20 meter per second. And that's the perfect answer for this specific question. So this is how things are getting solved, and they are applied using, right, how the sign conventions are applied that I showed you in front. Okay, so this was the first question. Now let's move on. Yes, this is the Galileo's law, right? This is the Galileo's law. This is important, right? First we need to I need to show you all this stuff, and then we will move on to the next part, right? What will be the ratio of the freely forward? See, a body is dropped height h. What is the distance travel in 4th and 5th second? 4th second and 5th second of journey. So what will be the ratio? Suppose distance travel into the 4th second is right s1, second it will be s2. Here we are having the Galileo's law, right? One new series will be formed. Right now I'm showing you all in front. Suppose u is equal to 0, it is dropped in 1st second. How much amount of the distance is traveled? S1, that is equal to half gt of square. In 1st second, we are having distance of 5 meter with respect to the reference point t is equal to 0. with respect to reference point t is equal to 0, what will be in second? S2 that is equal to half of g into 2 ka square, g by 2 that is 5 into 4 it is 20. Yes, 20. With respect to t is equal to 0, the second distance will be 20. So it means that this distance is 5, this distance is 20. What will be distance into the second? 15. In first second 5, in 2 seconds 20. So in second in 2 seconds 20, in second 15. What will be in third second? What will be in 3 seconds? It will be half g 9 whole square, that will be 45 meter, right? So now in 3 seconds 45, like this way, see, first second 5, 2 seconds 20, 45 3 seconds. So in first second 5, in second 15, in third second 25. 45 minus 20. So you can see the distance ratio is increasing from 5 to 15 to 25, right? So here the distance is increasing like 1, 3, 5, 7, 9, like this way. In this ratio it is increasing. First second 1, second 3, 5, 7, 9. 1, 3, 5, 7, 9. Like this way it is continuously increasing. That's the Galileo's law. In some of the reference books it has been shown. So in fourth second, see, 5, 20, 45. So it will be 5, 15, 25, 35, 45. Okay, in fourth and fifth second, it's 5, 15, third second 25, fourth second 35 and 45. So 9, 7 is to 9, okay, this series will be formed, 5, 25, I'm sorry, 5, 15, 5, 15, 25, 35, like this way, 5, 15, 25, 35, 45, like this way. Series of odds if it is dropped with u is equal to 0, okay. So this I want to show you all a new thing in front, okay. At the regular time intervals from the tap above the ground, the third drop is leaving the trap, touches the ground, okay. See, situation is there, this is a height of 5 meter, first drop when touches the ground, it was dropped from u is equal to 0. The third drop is leaving. So this is the first, this is the second, this is third. So first of all we need to calculate the time taken by the first drop to leave the touch the ground, it will be how much? So it will be h is equal to ut minus half gt square. On applying the sign conventions, we are getting t is equal to under root of 2h by g, and that is equal to 1 second. In 1 second the first drop is leaving the top and touching the ground, and in 1 second third drop is leaving. So it means that every 0.5 second, one drop is leaving. So what will be the distance covered by second drop into the 0.5 second? It's 0.25 whole square. So it will be 1.25 meter from the top, because this is our reference point. So in 0.25 seconds, I'm sorry, not 0.25, in 0.5 seconds, I'm extremely sorry, in 0.5 seconds, 1.25 meter of distance that has been covered, So what will be the height of the second drop with respect to ground? That will be 5 minus 1.25. So this will be 3.75. That we need to calculate the height, right, with respect to the ground. Okay, A will be the perfect answer for this specific question. This is also the nice question. Now we are going to use the equation of the nth this equation. This question is also nice. Okay, two more questions we are going to do in the motion under gravity. Okay, then we are moving forward. A body dropped from the top of the tower falling from the 40-meter height during the last 2 seconds. Okay, see, height of the tower is h. A ball is dropped. Dropped means u is equal to 0. This will be our reference point of projection. That is said that the ball covers 40 meters of the distance in the last 2 seconds. This distance is 40 meters. Right? This distance is 40 meters. In last 2 seconds, suppose from t is equal to 0, it has been dropped, it touches the ground at 2. Last 2 seconds, it means t minus 2 seconds. In between t and t minus 2 seconds, the distance is 40, it is given. We need to calculate the value of h. First of all, for this 40 meter, can I write it as, see, half of gt square minus half of gt minus 2 whole square. Right? For 40 meter, in last 2 seconds it is covering, na? In last 2 seconds it is covering. So I can write this equation as, right, 40 that is equal to half of gt square minus half of g of t minus 2 square. 40 is equal to half of gt square minus half of g t square minus 2t plus 4. We need to calculate the height of tower. So from resolving this, we are getting, right, the total time of flight from the position it is released to the point it will hit the ground. The total time taken by object to cover that much amount of the distance, height h, that is 3 seconds. So what will be the height of tower? H is equal to half of g, right, t square. So h will be g by 2 into 9, right, h will be 45 meter. Right, B will be the perfect answer for this specific question. Right, same equation, same sign of conventions. Now one more important question, and it's a really nice question related to motion under gravity. If a ball is thrown upwards, see, first of all, let's give you all a minute to solve this question, right? Okay, just read it, pause the video and solve this, right? Come on. Giving you the 5 seconds. 5, 4, 3, 2, 1. That's it. If a ball is thrown upwards from the ground and it crosses the same height at 3 and 9 seconds, then calculate the maximum height. From ground it is thrown, right, at 3 and 9 seconds, height is same, right, at 3 and 9 seconds, height is same. What does it means? If at 2 time instances the height is same, it means that particle is moving upwards and coming back to that same height. It is returning back to the same height. Right? Suppose the journey started at 0 second, first second, second second, third, fourth, fifth, sixth, seventh, eighth, 9. See, same height. And 3 on 9 seconds, right, object is at the same height. This is only possible, right, if the particle starts the journey at 0, 1, 2, 3, it is returning from this position like this way. So it's 3, 4, 5, 6, 7, 8, 9. So it means at t is equal to 6 seconds, particle is at max height. So it means that time of flight of the particle for entire journey will be 12 seconds, what we need to calculate? We need to calculate the max height. H is equal to half gt square. Particles take 6 seconds to move to the max height and again 6 seconds to come back to its original position. So it means, right, if I'm applying, see, this will be the height h, right? If I'm applying from this, u will be 0, particle is moving down. U will be 0, particle is moving down. H is equal to half gt square. So this will be half into g into 36, right? So h will be 18 into 10, right? H will be 180 meter. This will be the perfect answer. This is the height of the tower. If at 3 seconds and 9 seconds it is at the same height, right, it means that at 6 seconds it is at the topmost position, right? And using this equation, okay, it will be 180 meter. So guys, this was a question related to the motion under gravity. Okay, this question I'm giving you all as a homework, right? Okay, this question I'm giving you all as a homework, right? Kindly solve this stuff, right? Kindly solve this, please, right? Answer of this question, right, you can easily, right, solve. Okay, answer of this question, right, you can just comment beneath the video. See, as usual, I said you all before also, like in my previous session also, right, I always used to see your comments, I always used to read your comments, but I'm not having that much amount of the time so that I can respond it. Okay, I'm not having that much amount of the time so that I can respond it. Okay, so heartily apologize for that, but guys, please don't stop commenting beneath my video, right? Thanks a lot. You all always used to shower the love, right? And obviously, most special thing about my teaser, right? Okay, that teaser I'm making you the all thing for you all, right? So kindly please support me for the teaser, right? Okay, that is a glimpse of the entire chapter, what session is going on, right? So this is a homework. Okay, you can answer this stuff beneath the video. Now, relative motion. See, there are two things for the relative motion, 1D and 2D. If I will teach relative motion 1D, right, in 2D into the separate lectures, then it will create, right, a chaos for you all. I don't want to do that. Even I think this lecture is exceeding 4 hours and 15 minutes, right? And even that is quite pathetic for you all also, right? Because I don't want to hammer that physics stuff with you all, right, on your mind, right? I want you all to enjoy this class whenever you will come, right? Yeah, I want you all to enjoy this stuff, really. Okay, so this relative motion, right, thing, see, first lecture was units and measurement. This lecture is kinematics in 1D. This relative motion part I'm going to cover up, right, with 2D in my next session. Next session will be on the projectile motion, riverman problem, rainman problem. In this relative 2D problems, right, rainman and riverman is a relative only, 2D only, relative 2D problems only, right? So before that we will start, see, first in next lecture, first we will start with the projectile motion, right? Then we will move on to this circular motion, right? Projectile, circular. That I will see about the circular motion because it also going to come into the work energy and power in that part, right? Okay, but let's see. We will see the concepts of the projectile. We will see about the some, if possible, then circular motion, then some of the riverman problems, rainman problems, relative 1D, 2D concepts. Right, this all of this thing we are going to see into the next chapter. So whatever the fundamentals of the relative motions are there, we are going to conduct into the next. Stay tuned, right? Okay, heartily apologize for this because this thing, if I am going to teach this thing here right now, right, then obviously there is a gap between these two lectures for today's and the upcoming one, right? So obviously it is going to create a chaos. So rather than to create that, what we can say misconception, okay, let's adhere to the thing that this thing we will going to I will teach into the next session. Okay, so let's have the glimpse, right, what we have studied in this session. Okay, so I think we have done, okay, let's have the final revision, right? So can you end up this session? Okay, I think we have done a lots of things, right? Okay, I think it's easy to scroll it down like this way. Anna, it's easy to scroll right like this way. Okay, see, we started with the motion, right? We did the flow chart. Okay, one relative motion is that we're going to cover into the next session, right? And you always get connected also. You will get connected also, right? Feel connected. Okay, so motion, we seen definition of the motion, we seen the frame of references, right? We seen the inertial frame and non-inertial frame sign conventions, right? Fundamentals, position, path length, displacement, right? And sums related to it. And after that we moved on to the speed and velocity, average speed and average velocity, instantaneous speed and instantaneous velocity, sums related to it, right? Classification, we see the concepts of the uniform motion, right? We moved on to the sums related to it, and after that we moved on to the uniformly accelerated motion, right? And after that we moved on to the most important methods of it. We saw the sums related to it, and after that we moved on to the right the calculus method sums, right? And after that we moved on to the graphs fundamentals and types of graph we saw, right? Okay, and after graphs we saw the concepts, right, of the graph conversions, right? Okay, and after that we saw the sums related to it. I gave you the homework also, right? This one is a homework from my side. Okay, whatever the homework questions I have given, I want answers into the comment box, right? Please do that. It is a kind of a response for me, because this is a virtual session going on now. I'm not aware what actual things are going on, right? How much amount of the things I'm delivering, right? Is the efficiency is 100%, whatever I'm delivering in front of you, everything you are getting it or not, right? So I want that response. So please answer that comment box, answer that homework questions into the comment box beneath the video. Okay, so motion under gravity. Okay, we saw this concepts, right, assumptions and all of those stuff, and we saw some of the important stuff, sums related to it. Okay, relative motion we are going to see into the next section with the awesome visualizations, right, and some sums related to it. Okay, so guys, it's time to move on, right? So again, our next lecture would be for this champion series. Our next lecture would be right based on the motion in 2D, right? So guys, it's time to move on, right? This is Indrajeet Singh signing off from the desk, right? Bye bye, Sat Sri Akal, right? Okay. First it was the units and measurement. This is 1D. Now next 2D is going to come, right? So guys, this is Indrajeet Singh signing off from the desk. Bye bye, Sat Sri Akal, and namaste from my side, bacha ji. Bye everyone. Stay at home amidst the pandemic, right? Stay home, stay safe, stay healthy. Take care. Bye everyone.